Hello. Good morning, folks. We're back, Paula. We survived. I think you're on mute. I still can't hear you. Hang on, that's just maybe my end.
No, it's definitely me. It's 100%
right,
me. I haven't had enough coffee this morning, clearly.
Yeah, I have my coffee right here.
Nice. How are you doing, Matt?
I'm good. Yeah, I thought it was a fabulous day yesterday. Lots of interactions from the community. Lots of fab talks, and I particularly enjoyed the pub quiz to end the evening.
Yeah, I certainly enjoyed it. I wouldn't say I did very well in it, but it was fun. It was really good fun.
So, what stuff did you enjoy yesterday?
Wow, that's a tough question. I really, really enjoyed Cheryl's opening talk. I thought she spoke so from her heart, and it was such a wonderful way to start the day. I also really enjoyed some of the slightly different talks. I really enjoyed the overview from Florian from STEMets, just talking about the work that they do. I really liked Anne Curry's talk to end the day with talking about, the climate and trying to think about what our cloud providers are doing and just the nature of how complicated it all is, which I thought was fantastic.
Yeah, I love Anne's talks. I've heard her talk quite a few times, and
yeah, she's fantastic.
Always really interesting. I also
how about
really
you?
like. Yeah, I really like some of the same stuff as you were talking about. I thought the personal perspectives on community from both Cheryl and from Salman Iqbal were both really, really great. And these kind of events are all about that without the community, technology is really not as impactful. And I think that's one of the fantastic things about the cloud native space is that all over the world we've got these really powerful grassroots communities that are driving forward that technology adoption, helping each other understand the best ways to go, and kind of preaching the word of modern computing and how we transform things.
Absolutely. I have to do a quick thank you actually to just emphasize how kind the community is, because I was accidentally live this morning on YouTube without realizing, and some kind person, Bruno Gabriel da Silva, very kindly told me. So it just goes to show how kind our community is, and I really greatly appreciate that. So thank you.
That could have gone horribly wrong.
It could have gone horribly wrong, and luckily it didn't. So thank you, Bruno. I appreciate it.
I think we've also had lots of nice comments from folks out there who attended yesterday about how nice it was to have a mix of different kinds of talks, with particular reference to Anne's talk and to Katie Chong's talk as well, which
absolutely.
were both kind of dealing with the world we live in. Technology doesn't exist in isolation, and the sort of things that are impacting on our society we have to recognize and think about when we think about technology.
For sure.
Right. Okay. So for folks just joining us for today, welcome to Kubernetes Community Days UK 2021, day 2. And we've got another action-packed day for you, some fantastic speakers. We should probably go through all of the things to give a heads up again for folks who are just joining today. So thank you to all of our speakers, yesterday's speakers and today's fantastic lineup who are yet to come. If you could advance the slides, thank you. So we want to thank our sponsors, without whom this event could not have happened. So Sneak, Control Plane, JetStack, Sysdig, Storage OS, and our technical sponsor, Tramshed Tech. This event is entirely for charity. So outside of the cost of actually putting it on, all of the money that's raised from the sponsors will go straight to our charity partners, who we'll talk about in a second.
Absolutely.
Next slide, please. And we've also had some fantastic workshops from our sponsors and from other companies in the ecosystem. Please do try and attend these workshops. There have been all the way through the week. and you know, support our these companies who are helping to support our community. So thank you, JetStack, Control Plane, SUSE, Solar.io, Container Solutions, and Sneak. And you can find all the details of that on the website, KCD UK, workshops.kcduk.io. And thank you to our watch party sponsors. I've spent the last, yesterday and today in the watch party in Manchester. We're in Work Life. So if you are in Manchester and you want to come and hang out, please do come and join us here on the first floor. So Work Life have put on a fantastic setup for us here. So thank you to them. And thank you to Softiron and Tramshed who've sponsored the watch parties both in Manchester and in Cardiff. And these are the two charities that we are supporting with the event. We haven't done the final toss-up of how much those donations are going to be, but it's pretty significant. So STEMETS and Protect Earth. I think STEMETS talked yesterday about what they do, and Protect Earth are talking later on today. Paula, is that right?
They are, yep. So we've got Phil from Protect Earth is coming to join us at 10 to 2 to talk to us a bit about what they do.
Fantastic. Okay, so I think the next bit is on you, Paula, I think, aren't we?
So we do have some housekeeping before we get started. The code of conduct that we are governed by is the Linux Foundation Code of Conduct. So you can see the link here. Please have a look at it. Even though we're a virtual event, we still need to be kind to each other and respectful. So please take a look. If you experience any issues or if you witness any issues, please do report directly to the organizers. You can contact us at hello@kcduk.io or via Slack. If you have any issues that you don't want to report to the organizers, but you would like to report to the Linux Foundation, you can contact Angela Brown, and Angela's email address is here and also in the code of conduct. If you want to contact any of the organizers directly, you can see the lineup of organizers here. Here is the amazing organizing team of people who I've been working with for the last few months. Please feel free to message any of those people directly to say thank you or to report any issues. For Slack, we're using Slack as our main source of communication. So you need to be part of the Cloud Native Foundation Slack workspace. If you're not already a member, you can go to this email address, slack.cncf.io, and you can join. And the main channels that we're using, KCD UK is the main Slack channel for general conversation, for networking, for introducing yourself. And then we have two specific Slack channels for asking our speakers questions. We have the Track 1 Slack channel and the Track 2 Slack channel for asking the individual questions. Also, we're using YouTube chat. So however you want to communicate with us, if you put a question in for the speakers, then one of our team who's hosting will be able to ask the speaker the question on your behalf. And the speakers are also hanging out in Slack. So if we don't get around to answering a specific question, then the speakers will be able to answer directly. If you haven't yet registered for the event, it is not too late. You can sign up at our website, so kcduk.io, and then you can get some cool swag that will come from the organizing team ourselves that we've put together and also from our sponsors. If you're following us on socials, then our Twitter account is kcduk_io. The hashtag is KCDUK. We're also on Twitter. We had a few mix-ups with YouTube yesterday, so apologies again for the changing of links. But if you go to our YouTube channel, you will see Track 1 is streaming all day on one link. And there's also a separate channel for Track 2. The link for that is in the description, is on the About page. There's also a lovely video of Lewis talking about where you can find Track 2. The agenda on our website has also been updated, so hopefully you'll track us down. But if there's any problems, please let us know. Obviously, if you're watching me, then you've probably found Track 1 at least. So if you can't find Track 2, let us know. So I think that's all of the housekeeping. One other just well wishes I'd like to send. So one of our speakers, Lucas, sadly is ill today. He can't make his talk. So we've updated the agenda. We send him all the best for a speedy recovery. And what we're hoping is that when he's well, he will be able to record his talk that he was planning to present live, and then we'll put that on the YouTube channel ready. So best wishes for a speedy recovery, Lucas. And now we are ready to go on with the show, Matt.
Yes. Well, good morning, Amanda. Can you hear us? Oh, no audio yet. You can't hear me either. Okay. Slight technical problems. Just bear with us here, folks. I'm still not hearing you, Amanda. You are not on mute from what I can tell. We try.
I've got you.
There we go. Fantastic. Can you hear us?
Slight panic. I can
Brilliant.
indeed.
Yeah, it's been one of those conferences. The last 2 days have been slight panics in the starting keynotes. So welcome, Amanda. Thank you so much for joining us. So I am slightly biased, but Open UK is an absolutely fantastic organization promoting the open source software, open hardware, and open data across the UK. Amanda Brock is the CEO of Open UK and is our opening keynote speaker. So would you like to share your screen, Amanda, and we'll get you on the way?
Let's have a go at this and see how it works.
There we go.
Okay, don't get too excited. Let's see if we actually get a deck up here and a presentation. How are we doing?
Looks good. Fantastic.
Yeah.
The stage is yours.
Okay. Well, good morning, everybody. I'm Amanda Brock, as Matt said. I'm the CEO at Open UK, and we're the industry organisation in the UK for open technology. That's open source software, open hardware, and open data, sometimes referred to as the 3 opens. And as an organisation, we're about the business of open source. So we're an organisation for everybody who's working in open source throughout the UK, wherever you're from, whatever you do. And I want to start with a huge thank you to everybody here. And I want to thank you for having me along today, because it is very rare for me to get to speak to probably, undoubtedly, one of the most important groups in the history of technology. Now, some people would say that flattery might get you everywhere, but that's not flattery. That's hard fact. And if I could make my slides move forward, I would start to share some of that fact with you. Right, what's going on here? Sorry, guys, just bear with me. Here we go. Let's see if there we go. And we've gone too far. No, we haven't. Right. So the reason I know this is hard fact is that Open UK started this year for the first time to produce reports. And of course, you know, we're quite logical, analytical people. So we started at the beginning and we went out into the marketplace to see what was already there. And in pulling together phase 1, what we did was we brought together the literature that exists across the technology sector about open source. And that was a huge range of different reports. I've put the URL up there. You can go online, you can download it, you can read it. One of the reports we looked at was the Cncf annual report from 2020. And we got them to give us stats cut for the UK in a way that hadn't been done before. And what we were able to see and to prove without a doubt is the importance of your community, the importance of this community to global technology. Because in fact, where you guys sit is the 5th biggest contributor to Kubernetes, to cloud native globally. Now, when I say you guys, when I say everybody here, I mean the Kubernetes community in the UK. That UK community being 5th biggest, think about it. We've got countries like India, China, the US contributing more than us. If we scale up that level of contribution on a per capita basis, you're probably contributing more than any other individuals in the world to this critical software at this stage in technology development. And I don't think that any of us can deny the importance of where Kubernetes is taking the cloud environment and where that's taking business, industry, and increasingly the public sector. So what we're now seeing is sectors like the energy sector looking at how to open up. I'm sitting on an advisory in the UK to the Energy Sector Digitalisation Task Force, and they're working out what software to build their platforms on. It's going to be a no-brainer, right? So we worked with a number of people from your community, and we still are, and we will on an ongoing basis. And I should say that any of you who want to engage with Open UK, contact details for me are on here. You can also contact hello or admin at openuk.uk, follow us on Twitter, drop us a DM. We're always ready to engage with you. We spoke to somebody who I know you're very familiar with, Matt Barker, and he's one of the people speaking to you guys in the last 2 days. Now, in speaking to all of you, he's one of the leaders. And if you look across the program from the last 2 days of this event, it is incredible. You have a significant proportion of the Kubernetes CNCF world leaders sitting here in the UK. So it's not just about scale of contribution, it's about the leadership that's being shown in this space. And that's what's making you really special. Now, Matt's one of those people you can't say anything bad about, and he's also our entrepreneur in residence at Open UK. We've worked, as I say, with many people from your community, including Cheryl, who I know has now moved on from CNCF, but who I think is still going to be running her meetups. So we've heard from that community within our reports, and I'd really encourage you to go to them. We've done phases 1 and 2, and we'll have phase 3 on the 13th of October. Year on year, we will produce updates to those reports. If you've got suggestions for organizations we should showcase or how we do it better, come and talk to us. Within the reports, we didn't just look at CNCF, we looked at Red Hat and others, and you can see how important your software, Kubernetes, is viewed. We then worked on the European Commission's statistical empirical survey and outputs, which were published, I think, 2 weeks ago, but shared back in February. So although we published before them, we were able to use their work. And what we saw there was using the European Union's figures, we got to a contribution year on year to GDP as at 2019 of 43.15 billion, up to 43.15 billion. Now look at those numbers. The European Commission before Brexit was saying there were 490,000 contributors, 490,000 developers around Europe contributing to open source. As we Brexited, they reduced that to 260. Now, unsurprisingly, that's not a number they shout about, but we should be. And one of the things that I've seen here in the UK is we're just too shy. How often do you tell someone you're part of one of the biggest movements, one of the most important small groups in technology, in the history of technology today? I bet you don't. The 230,000 of you who have exited the EU with us on Brexit form a community of developers, but we are only able to calculate on stats 126. So if I was to make that 230, I'd be almost doubling the 43.15 billion that open source is contributing to GDP. And using statistics provided by TechNation, they are saying that that is 20 to 40% of the digital economy. Now, I would challenge that we're worth much more than that as an overall open technology community. And I suspect that we're up to about 60%. I haven't put in, and I probably should have, some stats from phase 2. And I'm going to encourage you to go off and look at that, look at our website. You'll see there, I think it was I'm terrible with numbers. I think it's 97% who are using open source and 89% who are running it from that first survey. And again, I'd encourage you to engage with us. We will run that survey again in Q2 next year. Now, if I take a slight step back, Open UK, I said, it's the industry organisation for the business of open technology. Open source software, open hardware, and open data. Now, we rebranded into this new, very, I think it's distinctive and sort of modern logo earlier this year. I joined in 2019, and I was given a remit that I could shape an organization that would be the future-looking geographical organization for open technology, open source. We brought in the 3 opens straight away. But we've also shifted, and I keep banging on about being the organization for the business of open source. The other organizations like us across the globe represent the local companies. They represent the SMEs. Now, we also do. They are a constituent part of what we do, but they're not the only part. Many of our UK constituency work for international companies. They work for non-technology companies. Some work in open source, some work in mainstream tech. All of you are welcome to participate in Open UK. And again, we have shifted. We started with a purpose that was very focused on the UK. Unsurprising, January 2020, we were trying to find our way. This July, we have reconfigured that purpose with Matt and the other board members, and he is biased. We've reconfigured that purpose to have a more international and more realistic reflection of what we actually do. And we're developing UK leadership with and in global collaboration and open technology. We've joined all the major organizations that we're aware of. We put people forward to sit on their committees and boards. If you're interested in doing any of that on behalf of Open UK, we'd love to hear from you. Jen Ashley is our partnership director, and she, a volunteer, is pulling together people who sit on those and doing reporting and things with them. And Matt rears his ugly head again, if you don't mind me saying, in the back of this photo. This is our one and only physical attendance at a conference as Open UK under my remit. Who knew? I had 20 conferences booked last January. Anyway, this is us at FOSDEM, and it was a really important FOSDEM. It was our first as Open UK in this guise, and we did a tea and biscuits with the Brits giveaway. We wanted to engage with people across Europe as we were Brexiting, and I mean as we were Brexiting. That stand on the right is on the 1st of February 2020. If you look left, you'll see Cheryl, myself, Jonathan Riddle, who's our awards chair, and Kavita Kapoor, who is our chief learning officer, outside the commission. And I think that's sort of bang on midnight, just before, because the lights went out. And there was a message for us to take away from the commission as we Brexited. The lights went out on us in Europe. But we don't want that to be how we feel about open source. It's not local source, it's open source. It's open technology, it's about international collaboration. And in Open UK, we want to give a message of belonging, and a belonging for everybody. We have a belonging letter that we ask people to sign up to, which looks at how we can start to measure statistics and metrics about our engagement across communities and within diverse and digitally excluded communities, as well as others. And for us, diversity means everybody, and we want everybody to feel that sense of belonging. And that comes not just from me, but from our board, from our leadership team, and from our ambassadors. You can see that we've got a strong group of people, many of whom in this Kubernetes space you're going to recognize. The ambassador program has space for up to 50 people. It's not something that's, a board member's asked you to do. If you're interested, come and contact us. We want you. We want you to work with us. We want to engage with you, and we want you to share the message. So what is that message? Well, we work on 3 pillars: community, legal and policy, and learning. And what we want to do for the UK is ensure that our community has a voice. Those 230,000 plus developers I was talking about, whether they're in Belfast, Cardiff, Swansea, Edinburgh, Kent, Essex, whatever, we want you all to come together to create the power of this community. And it's working. So we are building this visible and loud voice across our open communities in the UK. We've used an awards. We have one running now. We have a short list of 23, 8 award categories. Last year, we created an honours list. It was a bit of a joke. It was meant to be a one-off to cheer everybody up in Brexit. However, that bit of a joke, that me thinking this would make everybody smile at midnight on New Year's Eve of our Brexit year, had nearly 300,000 engagements on Twitter. That's with 1,000, I think it's 1,200 followers at that time. That's nothing to do with me. That's nothing to do with Matt or anybody else on the board. That's your power. That's your community's power and what you can achieve. Sorry, I'm welling up. I find it just incredible what you've done. This wasn't just in a single tweet. We had 460,000 impressions across January on Twitter. I mean, I don't think you can buy that, to be quite frank. We also, I didn't expect to well up. I've been locked up on my own too long. We also try to influence legal and policy. And I think we're being successful. We spent a long time knocking at doors, trying to get into government. And that's shifted, that's changed. Matt, I don't normally cry when I present, I'm sorry. It's just seeing those slides. I've not looked at it for a while. What we see in legal and policy is that the European Union, the Open Source Observatory, recognised us within months as the power and open in the UK, as the actor. That legal and policy group's got about 18 to 20 lawyers. It's got policy people, it's got advisors. If anyone's interested, again, the door is open. We submitted, and we were the only non-US organization to submit an amicus brief in Google v Oracle because it mattered, it impacted us. And of course, the decision went the right way. That's not guaranteed, it's litigation, but it was worth putting our power behind it, your power behind it. If you have a quick look at our website, all of our submissions to government are on the site, they're all visible. We are increasingly trying to respond to the devolved nations as well as the UK and EU proposals. And we really stuck our neck out around Brexit and this geopolitical shift. We made a calculated risk decision and we joined Gaia X. And Gaia X has been built on open source software. It is about open data. It is the European Union's Federated Data Services project, which is building a platform for data in the EU. And Open UK was described as the UK lifeline. We were one of only 2 organisations that stepped up and joined from the UK. And I hope that you'll see that as we emerge in the next sort of 6 months, where we may well be leading the hub for the UK. On data, that's obviously just as important as software. You can't have a software model today without data. And we submitted to the National Data Strategy consultation. We ended up with 2 direct quotations from our submission. Now, Chris, who runs that, must have gone through it with a fine tooth comb. I would never have found that, but he found those and they're highlighted on the site. We've done our 2 phases of a report. Third is out on the 13th of October. Importantly, phase 1 literature review, phase 2 focused on case studies and the survey. Phase 3 is an attempt to bring those together. And it's an attempt, it won't be perfect. It's our shot at trying to show the economics of open source in a new way. We're trying to look at how open actually generates value. Now, the other benefits that come from sustainability, from skills development, they'll be in there too, but we want to shift the economic model. Even the European Union report, it's almost a year old. It's talking about total cost of ownership. It's looking at contribution, lines of code in. I think that's out of date. We haven't just tried to do that on our own. We've already held 2 international workshops. We're going to do those quarterly from 10th of December. Anybody again can come along to those, just drop us a note. And what we're looking at there is what reporting is being done, how people are calculating these figures to try and create benchmarking and consistency. Again, I'm really happy to share stats with you. This is the MUV, which has how the comms and press measure your success in communications. You'll see that over the 2 reports, we've got about 150 million. That does not mean clicks, sadly. That means that those publications get that traction. I touched on sustainability and I'm conscious of time and I will get you back here by 10:30. I'll get you over the line, but we're going to go fast. We are building a blueprint for the carbon negative data center of the future. We'll be sharing that at COP26. I don't have a better image, but this is a CAD drawing of the site we will have at COP26. We'll have 150 people in a main dome, 50 in a learning dome. Francis Maud, the former cabinet minister who set up GDS, and who has worked so hard on opening up technology in the UK. He will be keynoting it for us and we hope to have ministerial presence. It will all be streamed. I'm on the final lap, Matt. So learning, our 3rd pillar. You can go back to this deck. I'll share it. Last year, we started with a competition. Pandemic hit us and we pivoted and we created a course for the kids in the competition. It escalated. It was really, really well received. So we shared it as a summer camp and we gave away over 3,000 of these glove kits. We entered the GNOME Community Challenge and we got runner-up. We almost won. The glove kits this year, they are not being made anymore by Pimeroni. What we've done is we've built a glove in the UK. So you'll see made in the UK by Open UK. Danny Abacallum, who you all know, his dad has arranged seamstresses to stitch the gloves because kids hate doing it. And we're incredibly grateful to Danny for sorting that out. But also we've pulled together 5,000 of these gloves that we're currently giving away. 3,200 are without microbits, so kids who already have a microbit can use them. 1,200 are for digitally excluded kids. If you would like a glove, go online, openuk.uk/openkidscamp. You can have a free glove for a child. They need to have a microbit. If they don't have one at home, which they likely will, they'll get one from a library. We will be giving them everything else they need. If they're from a digitally excluded community, please go through community leaders to ashley.monagle@openuk.uk. Email address is on the website and you can have one. Very, very quick wrap up. I see, in addition to our 3 pillars, sustainability, security, and OSPOs to be really important in the future of open source, and we're working on those. We've brought together a group looking at sustainability led by Christian Perino, who's ex-Canonical, but also spent many years working in sustainability. We have a strategy and policy, all Creative Commons, help yourself. We have brought the lovely Matt Barker, who I've known since he was a lad, in as our entrepreneur in residence. You know, Matt, early stage Kubernetes founder. Importantly, and this may be of interest to some of you, as well as the future founders work, you'll see a report next week, short, simple report on the state of open in the UK from a founder's perspective. We will be running training from end of this month, beginning of October, free to attend, 10 sessions, looking at things like product development, commercialization of open. Anybody can come along, they'll be recorded, we will share them across communities so that incubators, etc., have them. But importantly, there'll be a form to fill out if you want to apply for the program, and the program will include mentoring. We'll have mentoring, we'll have a business surgery for your startup, and Matt will be selecting the 10 to 15 organizations that can have that. And then there's me. I'm not going to tell you much about myself. Have a look at LinkedIn if you want to connect with me. I spoke at 100 of these gigs last year. This is something about our press in year 1 and year 2. We went from 229 million MUV to 2.79 billion by July. So they're taking notice of us. And finally, I have a book that will be coming out with my name on the front. I'm the editor. It is the only time I will be the editor ever. It's a horrendous experience, not one I would recommend. But the book will be open access, and it's something that you will be able to use probably from January, February, free of charge. So we will be pushing that out with all the legal and policy information for open source. And that's me. I think I'm a minute late. I'm sorry.
No, you're fine. That was fantastic, Amanda. Thank you so much for doing that. I think the emotion there just reinforces, you know, how dedicated you are to this task and to all the communities that we support. We've really tried to hold a message, you know, throughout this conference that, you know, community is the thing that really changes the outcomes of technology-based things. And, you know, I think your talk really made that point very strongly as well.
Thanks, Matt. I honestly don't normally cry when I'm presenting. So
that's the first time I've seen you cry.
Anybody. Oh dear. Well, look, thank you very much for having me. If anybody wants to follow up, please do. And it's really great to see you all getting together.
Yeah, and we should say there's lots of opportunities to get involved in Open UK as a volunteer. If you want to be involved with some of these initiatives, either on the kind of government and policy side, or in learning, or in any of the things that Open UK are engaged in, there's lots and lots of ways to get involved. So check out the website and reach out to any of us who are involved in the organisation. Brilliant. Right, Paula.
Fantastic. That was. I was also like, but I heard Amanda kind of welling up. That was quite emotional. So thank you. That was fantastic. Well, we'll move on to our next talk. So our next speaker is Paul Fremantle from Weaveworks. Paul is going to be talking about clusters as copies, which sounds quite interesting. So Paul is joining us live, but we will be playing his talk, and then we'll be going back to ask him some questions.
Hi everybody, my name is Paul Fremantle and I'm the VP of Technical Product Strategy at Weaveworks, and welcome to my talk, which is on clusters as copies. I hope you enjoy it. So I think we all know the analogy of pets versus the idea that we used to treat our machines, our server setups, as pets, and we would SSH in and kind of feed and water them individually, and now we have immutable, repeatable systems. I'm not a huge fan of this analogy, so I spent a bit of time trying to come up with a better analogy. And why don't I like it? Well, firstly, I think a lot of farmers do treat their cattle really, really well. I mean, here's one that is obviously groomed and looked after and a prize winner. And also there's large parts of the world that revere cattle or are vegan and so forth. And so I just don't think it's a very good analogy. I'd like to propose a different analogy around coppice. So coppice is kind of woodland where you just cut it right back to the ground and it regrows super fast. And it's usually woods like hazel and willow that are used. And it's kind of a way of farming woodland in a much more dynamic way than traditionally forestry is. And so my analogy, and thanks to a guy called Tim Seabrook who I discussed this with, is bonsai versus coppice. So bonsai are trees that are super manicured, looked after, individually crafted, and coppice is exactly the opposite. We just cut it down, it regrows. So what's this got to do with Kubernetes clusters? So the fact is, clusters are often still treated as pets. You know, the workloads, the Kubernetes makes it really clear that we don't treat the workloads that way. The workloads are managed through declarative pods. You can kill the pods, you can kill servers, but the fact is the overall cluster is often treated as a pet. And I've seen this both personally in working with people and helping them debug things and going in and fixing clusters. But also there's a lot of evidence that, for example, at AWS, lots of EKS clusters are on very old versions of Kubernetes, which is a kind of and have not been restarted or killed, are just out of date. So that's kind of a sign that we're not doing immutable recycling of clusters. So how are we going to do that? Well, I think that the right working model for treating things as coppice is Getups. I'm not going to go into all the key definitions, the 5 key attributes that the Getups working groups come up with, but the fundamental fact that we can use Getups, the way I see it is a kind of a remote control for coppiced workloads. And we certainly have seen this. So this is something called the Getups maturity model, which is based on working with a lot of different people doing Getups. And what we've seen is that as people expand their Getups usage, they start out by really working on workloads at level 1. They're Getupsing their applications, but then as they get further, they start to Getups the infrastructure and the clusters, as well as the config and the workloads. And then a few people like telcos are scaling this out and managing thousands of clusters at the edge using fleet management and using Getups as the key way of doing it. So I think this is a really key set of capabilities, and this maturity model is a useful way of looking at it. And, you know, to summarize, Getups is kind of using versioned, process-led remote control. Process-led because we use pull requests and merges to really track and review changes to that infrastructure, which is really cool. So how do we do this? Well, there's a key technology called the Kubernetes Cluster API, also known as KAPI. And KAPI is a project which basically enables you to treat Kubernetes clusters like any other Kubernetes workload through the Kubernetes API, using YAML to define it and using kubectl to deploy and declare it. So basically what you have is you have a management cluster, you deploy KAPI into the management cluster, and then whenever you deploy API calls against that management cluster, that affects leaf clusters that are created and deployed and managed by KAPI. And this supports many, many infrastructures, including Google, Amazon, AWS, Microsoft Azure, as well as vSphere and several bare metal providers like MAS and Packet. So this is super cool technology that supports multiple ways and places to run your Kubernetes clusters. So it's declarative infrastructure, and because it uses the Kubernetes API, we can use traditional GitOps tools built for Kubernetes to do the reconciliation. So this is really cool. We can use Argo CD, Flux, or I'm going to talk about a project called Weave GitOps that builds on top of Cncf Flux. So I'm going to do a quick demo and talk you through this. And what I'm going to do in this quick demo is deploy a GitOps runtime, Weave GitOps and Capi into a simple kind cluster running locally on my machine, sync it up to a Git repository, add some YAML into that Git repository and see it reconcile and create a leaf cluster. So I've already got a kind cluster created, and now I'm going to install Capi into this cluster using the tool ClusterCuttle, which is part of the Capi project. This is slightly sped up. It takes a little longer to install and get Cert Manager running, for example, but this is you know, just for demo purposes, I've sped up this recording slightly. Now I'm going to install Weave GitOps into this runtime. This is basically installing Flux. So if you know Flux, you'll see the customized controller, Helm controller, and so forth that you know. And now I'm going to go and clone a repository I've created. Now this repository literally has nothing in it apart from a README file at this point in time. So this is a really simple repository, and I'm going to now get this repository to sync with my management cluster. So using WeGo app add, that's now set up to sync. And I'm now going to pull up K9s, and we're going to look at what clusters there are. First, I'll show you what pods there are. You can see various Capi and WeGo pods running, and now I'm going to go back and monitor the clusters. Now I'm going to jump to the other half of the shell, and I'm going to go to that repository and create a new branch, and I'm going to check in a YAML into that branch. So this Docker cluster YAML basically defines a local cluster using Docker. I'm going to create my branch, and then I'm going to use a pull request and a merge to get that into the cluster. So I commit my change to the branch. I'm going to use the GitHub CLI client to create a new PR, submit that PR, and now I'm going to merge it. Now, of course, normally there'd be a review process, there'd be different people looking at this, but for demo purposes, you get the idea. So as soon as it's merged, you'll see Weave GitOps reconciles that definition, and when it starts to create a cluster, and actually there, it's provisioned already. So that was really nice. We provisioned a cluster just by basically checking in a YAML, doing a pull request and merging it. And so if you want to find out more about Weave GitOps, it's in GitHub. It's an open source project. One of the other exciting aspects of Weave GitOps is that we're creating a user interface for it. And this is an early preview. This is not quite released yet of the Capi template capability. So I'm going to basically deploy a template, and this template lets me tweak different aspects like the control plane, which version of Kubernetes, how many replicas to have for the worker nodes. It's going to do the same thing. It's going to create a PR for me. And this time I'm going to use the GitHub API, the GitHub website to merge the PR. So create the pull request. You can see that that's going to pop up the cluster definition there. It's still not created because we haven't merged the PR. You can see there's the YAML, and just have a quick look at that. And then I'm going to go back to the pull request and do the merge, and I can then delete the branch and go back to the cluster definition, and it's going to take a little time to reconcile. I have sped up this video as well slightly just because this is a very short talk, and you can see there it's found the cluster, and if I go and look at the status, you can see it's provisioned. It's still booting up, but and you can download the kubeconfig. So very quick demos. I hope they were useful. And quick summary. So I hope you like the analogy of bonsai versus coppice. If you think that's useful, then obviously please feel free to use it. I think it's perhaps more interesting and more challenging than pets versus cattle. The Cluster API is a really key project. If you haven't looked at it already, I recommend you do. It gives you declarative control of leaf clusters using Kubernetes APIs. Very, very interesting. Getups is an open source Getups tool that's basically a super nice wrapper on top of the Cncf Flux project. We're building a nice UI around it. This concept of putting Getups and Capi, I think, creates a really effective operating model for treating clusters as coppice, and I think that'd be of interest. And finally, that Getups maturity model, I just talked about it very briefly, but if you want more information, there's a white paper about that. And I think that's a really good way of tracking how your organization is using Getups and where to go next. And I will leave you up with some resources, and hopefully we have time for a few questions. Thank you very much. Well, I'm here live if anyone does have any questions, and please post them in the Slack or in YouTube, and I'll get to them. And I
Good
know
morning, Paul.
Good
morning. Sorry, I got slightly chucked out of the stream there, but so yeah, that was great. I love Getups. It's super cool, and I think if you know, that's really the ultimate expression of doing cloud native right. You know, in some ways, I talk a lot in my talks about how fully automated pipelines are really the biggest indicator that you are far along on your transformation journey, right? I mean, the technology is one thing, but you know, it's really this these automated pipelines that are the key indicator of how cloud native you are, at least in my view. I had one question that I had actually about Cluster API, which again, Cluster API is a project I love. I know quite a few people who work on it. It all becomes very Inception-like, you know, you start to think about it in your head, right? Because you need an API server to start with, right? What's the kind of current best practice on that sort of mini seed cluster that you use to kick things off?
So what I've seen done a lot is to use a kind cluster and then use that to create say an EKS or AKS cluster, and then pivot into that new cluster. So then that cluster that you've created becomes self-managed, which is kind of really cool. I don't know if people know about this idea of pivoting. It's basically saying, well, I've started the cluster elsewhere, but now I'm going to take control of it locally and have it manage itself. The other option is just to have is just to. I think it depends on what your model is. If you are, say, doing multi-cloud, you might say, okay, I'm going to choose one provider, spin up my cluster there, and then use that to manage all the others. If you're doing development, then certainly just having kind as the management cluster, or Minikube, or Docker Desktop, or some kind of local cluster is perfectly acceptable as well. But the ones like the kind of more production-y one is to start in a development cluster like kind, start to spin up a real cluster, and then pivot into that.
Awesome. I did like your bonsai versus coppice. I think time will tell whether that analogy sticks, Paul. But
Well, I think there's lots of ones, and actually, if you look in the Slack, Chris contacted me and pointed me at a LinkedIn post where he's also got a kind of vegan alternative to pets versus cattle. So I think there's a few people here who find that maybe that we do need a slightly better analogy. So, I'm not saying it's the best, but it's certainly nice to have that discussion.
Awesome. I'm just flicking through Slack quickly to make sure that we've picked up any questions. We do have a couple of comments. Very nice comments, makes more sense from Bruno. So obviously somebody that's starting to resonate. Bruno's also asking, so you move the controlling to inside the cluster itself. I think that must be a reference to the conversation that we've kind of just had, I think, about how Cluster API controls the building of other clusters, right?
Yeah, that's right. I mean, so Cluster API requires a Kubernetes cluster as a management cluster that can then manage lots of other clusters. But there is this also kind of pivot model where that can become self-managed as well. So you can manage that, but you do always need one extra cluster. And I guess we're probably going to see that also be offered as a service, because that's a clear thing. There's an obvious hybrid model where, okay, I'm going to run my clusters in whichever cloud I want, but I don't want the bother of running that management cluster, and I wouldn't mind if someone did it for me. So I expect as CAPI develops, we'll see people offering CAPI management cluster as a service as a kind of key control plane, and we've seen similar things. We've seen other SaaS models where you can spin up clusters. I think the nice thing about using CAPI is that it's a standardized way with direct support from the actual providers. So, Amazon contributes to the AWS provider, Google contributes to the Google provider, and so forth.
I think it says something about the power of the Kubernetes API as well, that, the API model is started to spin out into so many other things, including, spawning itself. Those standardized APIs become a really important driver in massive adoption of open source in that way.
And we've just seen cross-plane accepted into incubation in the Cncf, and that's another great example of a project which is saying, let's use the Kubernetes API as a standardized API for everything, including itself, but also then, RDS databases, all sorts of other infrastructure, and that that obviously takes this whole clusters as coppice idea even further, because then you can say, okay, I'm going to manage all the required infrastructure in a Getups way, using standard Getups tooling that talks to the Kubernetes API. So yeah, it's. I mean, I've been an API fanatic for 20 years. I started a company up that does API management, and this is the power of standard APIs, isn't it? It's something we've been hunting for 20 years, and Kubernetes is one of the examples that's really taken off as a really nice standard API.
Yeah, and I mean, all these things can then leverage all that work that's already gone into the API server, the controller managers, all of those kind of interesting reconciling behavior that is often where the hardest work actually happens to make all that work in the background, and it's the bit that no one ever gets to see.
And also cool things like K9s and Kubernetes observability projects and Prometheus and Grafana and Cortex and Flux and Argo and all these projects that work around the Kubernetes API suddenly give you like so much more power. So just the fact that I was using K9s without any modifications to see what clusters were running, super nice.
Yeah, brilliant. Okay, well, thank you, Paul. If you've got any
Thanks, Matt.
Paul,
Thanks, Paul.
I think he's probably hanging out in the Slack channel there. And Paula, over to you to intro the next bit.
Thanks, Matt. Thanks, Paul, for that great talk. So I am very excited to introduce our next speaker. I'm also quite biased because we used to work together, and I'm a big fan of hers. So our next speaker is Hannah Foxwell from Good morning from Tanzu Labs at VMware. Hannah's talking about where we started and where we're going. So that's going to be quite interesting. Hannah, over to you.
Awesome. Let me share my screen. Which screen am I sharing? This one. Okay, can you see a screen that looks like a nice slide and a title?
Yep.
Yep, people are nodding. Okay, great. Morning, everyone. It's really exciting to be here. My name's Hannah, and I'm going to talk about building platforms that developers want to use. But first, let's talk about why we need platforms. Delivering software is hard. A successful platform makes it easier for development teams to deliver apps into production. And an unsuccessful platform can actually make it harder. I think these stats here, these are pretty scary, but they're also believable based on my experience working with customers and helping to address some of these problems. Only 52% of net new apps ever make it to production. That's a really low number. That means 48% of apps that developers out there in the world are building ever get used. What an enormous waste of time and energy and potential. Now, 54% of software updates and upgrades efforts ever make it to production. That's an incredibly low number as well, especially when you think about how important, keeping up to date with patching from a security point of view is for all of our platforms and all of our technology that we use. And then only 51% of software that makes it into production does so in the planned timeframe. We don't build platforms for fun, even though building platforms can be fun. We don't build platforms to sit there empty, underutilized, gathering dust and waiting for a signal from our organization to just go ahead and decommission that platform. It's not delivering the value we want it to. We build platforms in support of applications that matter to our customers, our users, and our businesses. I feel quite lucky that I remember the days before the internet. There's lots of people now, the next generation who haven't experienced that. They've grown up in an internet-enabled world, in a digital world. But I do remember dial-up as a teenager. I remember getting excited about Yahoo and Napster and MySpace, and we've all been part of this evolution in technology. The internet has began and plays an increasingly important role in our lives. And, when we were younger, we saw those analog businesses around us move online, and those companies that were good at technology having an unfair advantage over those that weren't. With the Agile Manifesto in 2001, software development became agile and development teams started shipping code more frequently. And the businesses they worked for wanted change at an ever-increasing velocity. This was a really tough time to be in infrastructure or operations because it was so hard to keep up. There was this tension between dev and ops. Delivering software frequently and safely needed new approaches and tools, or that velocity was going to be at the expense of stability, and often was at the expense of stability. So I got involved in the DevOps community in 2011, and I've been working in this space ever since, trying to solve these problems for over 10 years now, which is a little bit of a scary thought. In 2011, we were using tools like Chef and Puppet to deliver infrastructure as code. But I remember the shift in the community as Docker came on the scene in 2013, and it changed the game. Suddenly, everyone was talking about Docker and how they were experimenting with containers. Developers simply loved working with Docker. With the development community embracing Docker, we needed new ways to manage these containers. And of course, in June 2014, Kubernetes was founded. I'm really fortunate working in VMware Tanzu that 2 of the 3 co-founders of Kubernetes actually are part of the VMware Tanzu team. And the origin story around Kubernetes is theirs to tell. It's not mine, but my story is really one about excitement and innovation and the impact that it had on the community as a whole. There was a better way of doing things. It was impossible to ignore. This evolution in technology was happening alongside my own personal evolution as I learned more and more about how to deliver software, as I experimented more with different methodologies and figured out what worked and what didn't. Like most people, I started with a focus on the technical problems that needed to be solved, configuration drift, manual deployment processes, et cetera, et cetera. You think that fixing those issues will solve all of your problems. But of course it didn't. And it didn't take me long to realize that the organizational, people and cultural problems were harder to solve and took far longer. How do you help an ops team embrace continuous delivery when every release they've overseen so far has taken down production? How do you help dev teams deliver working software daily instead of quarterly? These were the harder problems to solve. And so that's when I got involved in the human ops community to try and elevate that conversation and that focus to the people part of this problem. Technology was only one aspect of this. We had a lot of cultural and people challenges to address if we wanted to get better at this, if we wanted it to be not so hard. And in 2018, I got really lucky and joined a team of people who were on a mission to build wildly successful platform teams. We did this with hundreds of customers around the world, and we learned a lot. So my aim this morning is to share some of those important lessons I learned along this journey, building successful platforms, but most importantly, building successful platform teams. I'll say this to start with, building platforms isn't easy, and I don't want to diminish the technical aspect of this challenge. There are hundreds of technical problems to solve. But the way we approach platforms isn't simple either. Kubernetes is a fantastic abstraction layer. It gives you an API to interact with your infrastructure and operate your apps in a fantastic way. But when you think about delivering a platform as a service, this might not be the service you want to expose to your teams. And in many organizations I work with, it isn't the case. The surface area for configuration is massive. The complexity that we present to developers is a burden, or the perceived risk of giving people access to that API is simply unacceptable. And that's when you get the dreaded ticketing systems. You build walls of process around your platform, which limit access to only a few platform engineers. And this hurts developer productivity even more. Of course, you've then built another silo on your path to production. We've got the old DevOps problem all over again. Delivering software to production is hard enough, and we've just made it harder, either by exposing the complexity of the platform to our developers or by limiting their access to a point where they can't deliver independently. We've built a platform as a silo. And that is the key challenge so many of us face. How do we leverage this powerful technology in the right way? How do we make it easy to do the right thing and hard to mess up when there's such a huge surface area for regret your life choices twiddling? I love that quote. Kelsey Hightower said that Kubernetes is a platform for building platforms. That's a fantastic quote. I will quote that forever. It's powerful, flexible, extensible, but it's not a developer tool. I don't think, not yet anyway. The wall of YAML is real, and we need to really think about, what service are we providing to the developers in our organization for the app teams that want to land on these platforms. So how do we approach this problem in the right way? And how do we provide that platform as a service experience instead of building platforms as silos within our organization? The State of DevOps report in 2020 called out some really interesting insights that really resonate with my experience building platform teams as well. A product mindset is key to scaling DevOps and your platform. And higher levels of DevOps evolution mean more self-service offerings for developers. So let me start sharing some of my lessons learned. Some of the obvious pitfalls that you can try and avoid if you're just starting out on this journey. First, I'll talk about the difference between a project and a product mindset. When you approach your platform like a product, you build an MVP, but then you keep going. You iterate, you improve, you learn, and you evolve that product with the evolving needs of your users. You don't want to disband that team, and you don't want to reprioritize their time in a way that leaves your platform stagnant and brittle. It's amazing how often I see this happening in companies. What started off with a lot of promise loses momentum simply because people aren't working on it actively. And I hope it goes without saying that deadline-driven development is a really bad idea, especially when you're building a new service. I can't tell you the number of times as a consultant I was working towards a fixed date with no logical reason. It was a pointless target that inhibited the team's opportunity to learn, experiment, and innovate. It created pressure. It burnt people out. Whatever you do, don't do that. You want to set yourself up for long-term success, not short-term wins. The next thing I see a lot of in teams is field of dreams engineering. And what I mean by that is, if we build it, they will come. They build a platform in a vacuum, never speaking to the teams who might want to use it. I've seen a lot of time and money wasted on this approach. I'm talking millions, tens of millions. When you don't speak to your users about what they need, you miss opportunities to solve their problems. And you're more likely to over-engineer your solution. You try and build a one-size-fits-all solution instead of solving the most important problem that you face today. Similarly, big design upfront approaches are more likely to fail or to waste time. When you try to solve all the problems at once for everyone, you end up in analysis paralysis when you could have used that time to build, learn, and evolve. So here's a model that I found to be really useful when we think about building platforms and platform teams. I'll start with the application team and their mission, because this is really intuitive. The application teams that work in your organization, they want to build an amazing product and a valuable service to their users. The way I like to think about platform teams is exactly the same. They want to build an amazing product and a valuable service for their users, but their users are the developers. They're the application teams who are consuming this platform as a service. And of course, there's infrastructure somewhere, whether you're using a cloud provider or whether there's a data center that your company is managing. There's an infrastructure team, and that infrastructure team will only be successful if they build an amazing product and a valuable service to their users as well. When we provide a platform as a service, we want to allow the application team to both build and operate their applications. We want to give them the tools they need to be successful at that. One anti-pattern that I see frequently occurring is where the platform team are the operators of the apps. And that doesn't really make sense. They're not the right people to do that. They don't have the knowledge of what those applications are doing. The best people to support those apps are the people who built those apps. You build it, you run it. And so, what we really want to look for and what we really want to move towards is this setup whereby, you build it, you run it, and you own that service. You own that service and you provide that service to your users. So let's talk more positively. Instead of things that we shouldn't do, let's talk about some of the things that we can do, some really simple and easy things that we can do to get our platforms back on track. If some of those things that I was saying earlier were resonating with you, ask yourself why you're building a platform. Remember, we don't just build platforms for fun, even though building platforms is fun. We provide a service to developers. And when I say DevX, I'm talking about user experience for developers using that platform. Setting out your mission and building a team to deliver on that mission is the first step. Technology ought to be an implementation detail. Your purpose is to solve problems for your users. And when you're in a large organization and you're in a shared services team, you're supporting a large number of people, it can often feel like everyone is waiting for you and no one is ever satisfied. And, I've been there and I know it's not easy, and that, the pressure builds. And, some of the ways that I've seen to make this easier are, by creating that culture of learning and sharing, building bridges with your users, talking to them more often, sharing what you've achieved and what you're working on next in your roadmap. Show that progress, but also seek feedback. Is the thing that we've built good enough? What could we be doing better? Like, how can I help you more? Invite people to regular demos or blog internally, talk internally about what you've built. Really evangelize that platform experience that you're providing. We want to use technology to solve problems for our users, but we can't forget about the health of our own team. Don't let manual work grow to the point where there's no time left for platform engineering and working on new features. Make sure that there's always time to improve. In the Google SRE book, they recommend measuring toil and capping it at 50%, which I think is a really good way to make sure you're always automating the simple and repeatable tasks, making sure there's always time to respond to change, making sure there's always time for continuous improvement. as part of this, you'll need to drive towards self-service so that users can get what they want without ever speaking to you. This is the secret to becoming a wildly successful platform. Give your users documentation, APIs, tools that mean that you don't have to hold their hand as they consume your service. This then frees you up to solve more interesting problems and to evolve your platform. Getting software to production still feels hard for so many people. And I've been working on this problem for 10 years now, and I don't think it's going to go away anytime soon. We're still learning how to do this. And as technology changes, we'll have to learn and adapt with that. But as platform engineers and platform teams, we can help. We can help by delivering platforms as a service instead of building walls and silos within our organizations. And we can help by focusing on the developers as our users of these platforms. Thank you so much for having me this morning. I hope some of that resonated with you. I think we've got time for a few questions now, but also I will be hanging out in Slack if you'd like me to DM me or ask me a question in the channel.
Thank you, Hannah. That was fantastic. I am, as I mentioned earlier, slightly biased because I feel very passionately about some of those same things. I don't think we've got any questions yet on the Slack, but what I wanted to ask was, I love the way you frame it as it's not just about building platform, it's also about building platform teams. And you mentioned that there's, within the platform team, there's dev and ops. You need to be able to do both. I wondered if you could talk just a bit more about some of the roles that you've seen in platform teams, some of the individuals and roles that you could have in that might not be a traditional platform engineering role.
Yeah. I mean, I think I know where your question is going, and it's I think I mentioned it on one of my slides, but I didn't speak to it, so I'll speak to it now, which is about really having someone who is the product manager of that service internally. If you could imagine you're Amazon for a moment, or AWS, and you're providing a service through an API or something new, you've got a product manager who is really looking at the strategy for that service. What does it need to do today? What might it need to do tomorrow? And how do I make sure that people can consume it without needing to ask me questions? And I think when we approach our internal platforms in that way, and we put a product manager in place who values those things, we drive towards a better outcome for the users of the platform. The extreme end of it is, when you have your platform team in that silo who are interacted with via tickets. But, imagine if a cloud provider did that, how unthinkable that would be. And, these are the platforms that developers are accustomed to consuming. So if we give them a worse user experience within our own organizations, they will simply go elsewhere. Whether or not their policy allows them to go elsewhere is a different story, but they will try to go elsewhere. So
some of us are old enough to remember the hosting industry, Hannah, where management by tickets was exactly what used to happen.
Oh, I know. Yeah. I mean, it's I think maybe when you're starting out and your platform is new, you need to do what works. But I think the important thing is driving towards that level of maturity where your users can get what they need without speaking to you.
I also liked your comment about Field of Dreams development. I love that film. I think that might show how old I am, but I mean, I like that film, and I like the idea of kind of people think if they build it, they will come. But unlike Field of Dreams, that probably doesn't happen. And you talked about collaboration, which is, again, so important, as well as the platform team folks collaborating with the application folks. Are there other people that they should be trying to communicate with them? And I'm thinking more like compliance, security, that those types of groups.
Oh yeah, I mean, my little picture was so oversimplified, and in large organizations, you'll probably chop up those capabilities of your platform into different domains. You'll absolutely need to work with security, and I think one of the definitions of a good platform is that it is secure by default. It makes it difficult for developers to do something that would put the security of your infrastructure and of your applications at risk. So yeah, I mean, it's very dependent on the size and the maturity of the organization, but yeah, like I think there's a huge amount of teams that you need to work with, and sometimes I think security teams could benefit from that as a service mindset as well. How can we help the rest of the organization do the right thing with minimal amount of friction?
Absolutely.
Well, some of us in security are further along that journey.
Yeah, absolutely. I mean, sometimes you see security as gatekeepers, and sometimes you see security as enablers, educators. But there's all kinds of different ways you can approach these problems.
Awesome. Thank you so much, Hannah. And you'll be hanging out in Slack if people have.
I've seen some questions in Slack, so I'm just going to jump in there and start answering some.
Fantastic.
Thank you for having me.
Thanks, Hannah.
Bye. Right. So our next speaker probably needs very little introduction. Are we bringing him onto the stage? Is it happening? It's happening. So yeah, probably the most prolific live streamer in the cloud native ecosystem. His media empire includes Raw Code Live, Slash Looks Good to Me on Cloud Native TV, and of course, Cluster. It's David Flanagan. How are you, buddy?
I'm doing really well. It's nice to be here. How are you?
I'm good. I'm good. So have you recently become have you got a little one, a new little one?
You're so close. So I have a 3-year-old and I have a -2-day-old. So someone due within the next couple of days.
Oh, I knew it was either coming or just happened. So
yeah, it's close. I mean, I may have to just leave any minute right now, to be fair, but hopefully that won't happen.
Talk out of the way quick then. So your reputation clearly precedes you, because Dan Papandrea turned up from New York in the middle of the night last night.
A day early, I know. What's that all about?
To troll you, and he's not here today, so he missed his opportunity.
Oh, I'm sure he's got some tweets scheduled, and I know Dan.
Yeah, almost certainly. Right, I will pass you the floor and have at it.
All right, let me see if I can work this thing then. So I'm going to click the share send button because I am hoping we're going to be able to play a little bit of a video. Well, thanks, Tim. I believe you can. And this talk is called What I Learned, Fixing 50 Broken Kubernetes Clusters. So this is a little bit of a knowledge share from my series Clustered, which I run on my rawcode.live YouTube channel, where we break clusters and then try to fix them live in front of an audience. Now, a little bit about me. I'm a senior developer advocate focused on cloud native and Kubernetes, and I work for a company called Equinix Metal. I also am a Cncf ambassador and Influx Ace. I am the host of the official Kubernetes office hours, co-chair of Cloud Native TV, as well as host of LGTM, as Matt said. And my YouTube channel that I devote far, far too much time to is available at rawcode.live. Now, Clustered is really good fun. We are, I think, 25 to 28 episodes in right now, depending on if you count teams, solos, and the newcomer edition. And the general idea is really, really simple. I reach out to friends within the Kubernetes community. These are Kubernetes contributors and end users. And I give them a freshly baked Kubernetes cluster and tell them to break it whichever way they can. They don't give me or the other members of the Clustered episode any information on what has been broken. And we go live and we share our screen and we try to work through all of the broken bits, identifying symptoms and looking for cause and effect to see if we can get that cluster back online. And on paper, it's really simple. All you have to do is upgrade the clustered pod from image v1 to image v2. Of course, one of the things I've realized during the 20 plus episodes is that people are particularly mean, very, very mean. So I've got a little video to start. It's just a couple of minutes long, and I want to give you a taste of what Clustered is. So hopefully you can hear the sound. Hopefully it's going to play. Yeah, we still have no cluster DNS. kubedns has endpoints. Okay, that's after 8.
Yeah.
Let's see if Guy wants to jump in and give us a last bit of advice before we wrap this up. Are we close?
You've not looked at the configuration of core DNS. You've looked at the pods, but not how the pods are configured to run the DNS.
We have no DNS. Just keeps coming. All right. Did we miss something? Let's. I'm going to say cheat. I'm going to jump onto cluster 14 and grab the config map and see what's different.
What about?
Yeah, these are the exact same file. Yeah. So he told us to look in the core DNS config, and then there was nothing wrong with the core DNS config. That's just cruel. That's saying there's a few pixels. If this is a white space error in the core DNS config, I will be mighty frustrated.
It might not be a white space error. Damn.
He's mocking us now because he said your jumping back and forward showed a slight difference. This number seems arbitrary. Oh, you son of a bitch. I'm assuming there's like a weird bug, and I'm sure he's found it because he works at Skyscanner and they've got a level of scale that most people don't have. But something to do with this number going so high is maybe causing it to load an old config map in the pods or something. I don't really know. But the number being so high worries me. But we're now at the stage where I have to go and pick up my daughter. So
yeah,
I'm just going to bring Guy in to tell us what wonderful magical
what we should
crap this is. Yeah. All right, Guy. Lay it on us.
So when you were jumping back and forth between the working config and the non-working config, if you look really hard at the C in front of it in the Kubernetes config.
Oh, you bastard.
The C?
Yeah, it's not a C. No, it's a character which looks a lot like a C.
What?
So the Kubernetes plugin became authoritative for letter that looks like a C, luster.local.
All right. So that was particularly mean. That was a Unicode issue in the core DNS configuration. There we go. So that was the first time I ever changed the rules on clustered, and Unicode changes are now banned. What I love about that clip and that episode specifically, I mean, excuse my language in it, of course, but Guy had me questioning primitives, like complete basics, like why was I questioning the resource version going above an i8 or an i16, right? And trying to like overflow back to older generations. Like, of course, that would just not happen because it's obviously going to be an i32 as a minimum. But you get in this position when you're debugging, and I think that's really important, is that debugging these things is really difficult. And it's going to challenge all sorts of assumptions, and you're going to make wild guesses that will be wildly inaccurate. But getting things wrong is normal. And if we look at Albert Einstein here, failure is success in progress. We have to learn. It's through all of these mistakes that we learn the things that we need to learn. So I'm going to take you on my path of failure from clustered, all the assumptions that I made and the things that I got wrong and the things that I learned. So the first thing, and probably the most prolific attack surface that people use on cluster to break these clusters is the Linux system itself. Now, this is just a really shorter video just to demonstrate what we see.
Get some notes, man.
Let's see. Permission denied.
Oh. Let's check.
Ed, you've hit your first snag. There we go.
Okay. Make it +X.
Yeah. I need my autocomplete stuff. I'm lost.
You didn't install Fish while you're here too? I can type if you want.
Oh.
Okay. Nice.
Okay.
It's an interesting start.
Yeah. Do an ls-l-a on user bin change mod, or probably just bin change mod. Oh, bother. You don't even have tab completion? What is
No,
this?
I don't. Yeah, it's killing me. But hey, we'll make it work.
If you don't, I think that's
Oh,
probably
wait,
because
we
they've
can't
done something.
chmod that.
Yeah,
Well,
exactly. So
yeah.
just look at the whole/bin. Is there anything which is executable at all?
Well, LS is
No.
obviously.
All right, so take a look at this screenshot. This is the Teams edition. This was Red Hat versus Talos Systems, and Jiffy and the Red Hat team and his other colleagues removed the executable permission from chmod. Not only that, all the files and binaries that we see in white here also had the executable permission removed. So that's change attributes, chmod, kubeadm, kubecontrol, OC, which they were using as an alias to kubecontrol, SCP, so they couldn't pull in other files, and even Perl. And what I love about that is that it's really, really simple. A mistake that we could all make easily, and not something that everyone is fully aware of how to fix. So kubecontrol and kubeadmin was, you need those to be able to debug the cluster. Removing the chmod and change attributes was just plain cruel. And even removing the executable attribute from Perl allows you to actually execute syscalls on files really easily. That command is a lifesaver. You should keep a note of it. However, what we learned on that episode is you can actually use the dynamic linker directly to execute binaries on the machine that don't have the executable bit set. And in this case, we're using the dynamic linker to re-enable the executable bit on the chmod binary itself with the chmod binary. And I think that's a wonderful tip and a great debugging thing. Also, something I learned during Custard is Linux file attributes. I'm familiar with the chmod, the 777, the 644s, etc. But there are extended attributes on all files. And in fact, you can make files immutable. And I can't remember if it was Dan Finneran or Jason DeTibris, but they both, or one of them at some point, made the etcd write-ahead log immutable, breaking etcd. So these things are really, really cool, but not if you don't know they exist. The next biggest attack surface we see on Clustered is networking. So beyond Linux, they always like to try and mess with the way the systems within the Kubernetes cluster communicate with one another. And what we've discovered with networking is that there is a life after IP tables. You may be familiar with EB and NF tables. Something I wasn't aware of until very recently on an episode of Clustered is there's a concept of traffic control, a TC command for manipulating the packets on the device through quality of service rules. And of course, we've got Ebpf and XDP, which are being leveraged heavily by the Cilium project. Now, what I didn't know about IP tables before Clustered is that you can actually apply drop rules using the statistic module to apply a randomization effect to the drop packets, causing what appears to be intermittent errors at the IP tables level, particularly sneaky. Another common attack surface we've seen is people changing the DNS policy on the pods. There is a DNS policy in Kubernetes called default. It is by no means a default. It does not use cluster DNS whatsoever. And in fact, cluster first is the default DNS policy. So it looks like when you look at a pod spec and you see DNS policy default, you probably think that's all right, but that's a warning sign that you probably want to fix something. Something else we've seen is network policies with Cilium. Cilium can use standard Kubernetes network policies and apply those rules for you directly. But Cilium has extended that API with their own Cilium network policies as well, which add an extra layer of abstraction and obfuscation to what's actually happening within your network. Cilium also has cluster-wide network policies that will modify the traffic shaping across all the nodes in your cluster. All of these things are very tricky and delicate and need to be handled with care. There's some tips for working with networking. I'm not going to stand here and say everyone should adopt Cilium. Of course, you've got your own needs that have to be met, but Cilium is a wonderful CNI implementation, and it ships with something called Hubble. Hubble gives you a visualization and user interface into all of the network policies across your cluster and service communication, showing you in real time packets that are being dropped or accepted, allowing you to kind of trace all these requests through your system. It is a super power tool, and I encourage everyone to check it out. Even if you're not using the Hubble and Cilium, Cilium provides an editor for modifying and working with these network policies as well. You can go to editor.cilium.io, and you can actually start to build through a visual interface or dropping a YAML into the box to visualize the network policies that you need in your system. This is a really quick and fast way to bring in those network policies. And I've seen time and time again that teams are reluctant to do this because it's a dangerous and daunting task. Nobody wants to bring down their cluster networking. Now, next is etcd. This is the biggest, scariest one that we ever see. Like, I don't think anyone who has ever appeared on Clustered has been happy when etcd is unhappy. Nobody is actually that familiar with debugging etcd itself, and nor should you be, right? But there are a few things that you need to be aware of. Number one is we've seen many people now on Clustered attack etcd by modifying the quota or filling disks or writing arbitrary junk data into etcd itself. All of these end up with an etcd alarm. Now, even when you fix the problem by clearing up the space, removing the junk keys, increasing the size of the resource quota, that alarm stays in place, even if you restart etcd and all sorts of things. It was only through trial and error and pain that we realized you actually need to disarm for etcd to become healthy and happy once again. Another thing we've seen very recently, this was just last week on Clustered, is that Barco, a member of the Kubernetes office hours, decided to enable encryption very nicely on a clustered cluster. However, he only partially encrypted all of the secrets and config maps within the system. Oh dear. So what this meant is that we couldn't pull or query any default namespace config maps or secrets. There's a really cool trick to working with the encryption system in Kubernetes, and that is to add multiple keys and multiple providers. And in fact, the way that you turn on encryption is to enable the identity provider, which is the default unencrypted provider, add a new key, and then literally you get all the secrets and all namespaces as JSON and do a kube control replace to re-encrypt the values as they go in. The encryption in etcd and Kubernetes at rest is applied when modifying or writing to etcd. And the way to fix the partially encrypted problem is just to add both providers. So add a key and an identity. And in fact, the way that you do key rotation as well in a Kubernetes configuration is to add multiple keys and then remove the old key after you've done the get and replace. All right, so where next? That's a really good question, but there's something I want to address first. There are a lot of places that you can attack a Kubernetes cluster. And I've built this word map just to show roughly what's going on. But, we've seen people attack the CRI, the CSI. We've seen people attack the controller managers, even to the extent of recompiling the controller manager and publishing their own image, or recompiling the kubelet and publishing their own image, making things immutable, applying policies via Kyverno, JS policy, OPA, etc. People get really, really creative. The surface that you need to know in order to be successful in running Kubernetes is ever expanding and dangerous. And this isn't really a talk about failures specifically. I don't know if you've been paying attention to the quotes as we move through, but all of this failure things where I'm talking about the next area we want to address is a quote that tells you that failure is just a part of the knowledge cycle. The way that we learn is by dealing with these problems. And I think that is crucial. So what I'm going to encourage everyone to do is to remove hero culture, right? We don't need hero developers. What we need is the confidence and the ability to say, I don't know within our teams, within our organization, and if you're bold enough to do it in public. I get in front of an audience every week with Clustered and spend most of my time going, I have no idea what I'm doing. And I think I'm pretty good at this. And we have a duty and an honor to set a precedence for new people entering this industry. The hero developer is no longer a thing. So my journey next is taking me towards Ebpf. I have noticed through all of these Clusters episodes, the Ebpf probably has the answer to every problem that we've ever dealt with. And I'm going to use one slide just to try and show you what I mean by this. So Ebpf is really performant, has a bytecode compiled into the kernel that exposes tracing probes, allowing us to understand what is actually happening at the kernel level. There are some really great projects in this space for Kubernetes. Cilium, we've already covered. Falco by Sysdig is amazing for getting into the audit log and the events happening within the Kubernetes system. We have Inspector Gadget by the Convolt team and Pixie by Pixie Labs for completely autonomous, uninstrumented observability into your Kubernetes cluster. You should definitely check it out. Inspector Gadget exposes all of the snoops that I've listed here in a Kubernetes context. Exec snoop is a BPF program that will tell you every time a new executable is run on a machine. IO snoop, open snoop tell you when files are opened or being written to or being read from. And then there's all the TCP snoops as well, which are going to give you visibility into all the packets within your system. Ebpf is a superpower, and it's what I'm really keen and excited to be learning next. If you want to learn more yourself, there's some links here. I'll publish a link to the slides on the Slack channel momentarily, but check out the BCC examples at github.com/iovisor/BCC. And what comes next? I'm not entirely sure yet, but I'm looking forward to failing a lot more. Thank you for your time.
Hi, David. Thank you. That was excellent. I do wonder how you put yourself through live fixing of Kubernetes just continuously. It looks like you have fun doing it.
It is a whole lot of fun. Once you get over the awkward bit, like, oh, I'm just going to be completely confused. I'm going to have no idea what I'm doing. But it's through collaboration and pairing. You know, I'm not doing it alone. I have a guest with me. We have teams. We talk about the symptoms. We try and understand the problems. And it's through those conversations that we actually are able to share so much knowledge with the broader Kubernetes community. So
nice.
It can be painful at times, but it's one of the most rewarding things I've ever done.
Fantastic. Well, we're running slightly over, so I will say thank you very much. And then if there's any questions, if you're hanging out in the Slack for a bit, then folks can hopefully post some questions into Slack and you can take a look. So we are taking a quick break. Time for folks to grab coffees or water. Get yourselves ready for our next session. We'll be back in around about 5 minutes time. Thanks, everybody.
Hey folks, welcome back from break. I hope you all managed to get a coffee or tea, whatever your choice is. Now we are moving over to, so there's been a slight change of the agenda. Hopefully you've all noticed that. So we're staying with just one track one for now. Then we'll split on to 2 tracks at 12:15 due to, as Paula said earlier, due to one of our speakers unfortunately being ill. So now it's really looking forward to introducing Nigel Poulton, who's going to have a bit of a what we're calling an ANA, Ask Nigel Anything. But just to keep him in track, we've got our own Adrian Muat, who's going to be there to keep him in order and keep an eye on questions and stuff. So really looking forward to listening to this chat with the 2 guys.
So who's speaking first then, Adrian, you or me?
Okay, so I think that was my cue and I completely missed it. I didn't.
Hey, we're all good.
Yeah, it's like we've never ever done this before, eh? Yeah, welcome to Nigel. So Nigel Poulton, I'm not sure you need much of an introduction. Author, trainer, perhaps most famous for the Kubernetes book. And I think that's actually a good place to start. Because I have written a book myself, so I'm aware of how much work it is. But I think the fantastic thing you've done with like the Kubernetes book and the Docker book and so on is that you've kept it up to date. So you've done a lot of work continuously updating it. And I just wondered if you want to talk about that for a second and what that was like and how much work it takes.
Yeah, absolutely, mate. It's an absolute pain in the rear end to keep up to date. I say to people all the time, right, that I would absolutely love to write a book about technology that you can stick on the shelf or on Amazon or whatever, yeah, and it'd be relevant for 5 years, because it's so much effort to actually write a book. But something like Kubernetes, I do feel it's changing a little bit, right? But something like Kubernetes and containers and stuff that just seems to iterate so fast. It's really hard work. So I know when I first released the Kubernetes book, I think it might have been the first book on Kubernetes. I can't remember. It was certainly first or second, and so was my Docker book. But when I released it, it originally had 15,000 words, so 15,000. And I was the first year I think I updated it 3 times. And then I was updating it twice a year, and now I'm on to just annual updates. So the pain of actually keeping the content up to date is less for me now, because I do feel like Kubernetes as a project has matured. But one of the things I do with the book is I only tend to talk about things that are generally available or V1, stable. And back in the day when I first released the book, that wasn't a great deal of things. And that's why it was 15,000 words. I think it's 70,000 words or just over 70,000 words now. And that's a reflection of how Kubernetes has matured. Because again, I'm only talking about things that are stable. I mean, like, look, you would know, and everybody on the call will know that if we were to try and cover in books everything that Kubernetes does, like, I don't know, it would make the collected works of Shakespeare or whatever look small and interesting as well. So yeah, it's fun to write a book because, you get to interact with a lot of people and you get to influence a lot of people's lives and careers. And that's really, it can be a special thing in a humble way. But it was originally painful writing a Kubernetes book and keeping it up to date. And it still kind of is, but it's not as bad as it used to be. That's for sure. Yeah.
Yeah.
Hey, I've got a quick question for you. Do you want me to share my screen?
Yeah, sure. So I think we have there's a little bit of housekeeping. You can send us your questions for Nigel. So I think Nigel has kindly prepared a slide with some more information on where to go to share such information. So do you want to go ahead, Nigel?
Yeah, so make sure I share the right screen. So desktop number 2 here. You should see my slide. Yeah, getting started with Kubernetes, ask me anything. I'm assuming that we see that. Let's have the feedback if you don't. I'm going to just move it on one slide though. So basically for this presentation, it's an Ask Nigel Anything, but it's actually, Adrian doesn't really know this. It's an Ask Nigel and Adrian Anything. Now we have had some questions come in from Twitter and on LinkedIn already. However, we've got some places that you can ask more questions right now at the bottom. So I'm going to move it on another slide. So this is me. I've written some Docker and Kubernetes books. We've kind of talked about them. You can get them everywhere that you would expect to be able to get a book. I don't want really the focus to be on that. I want it to be on asking the questions. So I'm just going to slide it on to the first question. And I'm super interested in your take on all of these as well, Adrian. We can make it like, we're having a chat and everybody else is involved in the chat by asking the questions. I know that you've got to kind of monitor the different channels and stuff, maybe a little bit closer than I've got to. But we had somebody ask, will Kubernetes be easy? I didn't put who's asked this one, actually. Maybe I made a note of it. I know I didn't for that one. So I know when I talked about the book there, we said that like, at least writing the book is easier because Kubernetes as a project has got more stable. But I think to this question, there's so many angles. The first one that I always used to sort of struggle with is like getting Kubernetes. Like if you wanted to build it yourself, DIY Kubernetes, that was always really hard. And I always felt like you almost needed to be a Linux kernel engineer to be able to build like a production grade Kubernetes cluster. I feel like the hosted options on all of the different clouds that we have out there now really made on-ramping to Kubernetes or getting it in the first place or getting a production grade Kubernetes cluster. And I always use production grade in air quotes because it means different things to different people. But I feel like getting Kubernetes now is way, way easier than it used to be. But I still feel like we're not where we need to be. I do feel like the cloud vendors probably are. But if you want to build your own on-premises Kubernetes cluster and make it highly available and high performance and then be able to like keep it up to date going forward, I really don't feel like we are there yet. I don't know if you have any thoughts on that actual like process of getting Kubernetes at all, Adrian?
Yeah, I have a lot of thoughts, to be honest. I think we need to split into two things. You seem to have kind of focused on how hard it is to actually get Kubernetes up and running.
Yeah.
And I think you're spot on. Like if you use like AWS or GCP and they've got the managed things like JKE and so on.
Yeah.
It's relatively straightforward. But what's really hard is like the ongoing maintenance.
Yeah.
And that's why Google have, is it Autopilot they called it? I can't remember.
Yeah.
And to be honest, the main thing I see in the complexity is just Kubernetes tries to be everything to everybody. And it's got so many use cases it covers. So I don't think Kubernetes itself will ever be easy, but I think what we might start seeing is like platforms on top. So I think a lot of enterprises, and I think that this is already happening. You see enterprises with their own platform as a service, basically. So they have platform teams that basically make Kubernetes easy for the developers. Mm-hmm. So I think that's maybe the direction it'll go in.
Yeah, so I've often thought about that at some point, I really believe that Kubernetes will just be there and that it won't be this thing that you almost even have to think about. It'll just be like, we're deploying our applications and, we're doing everything that we need to do with that around scaling and the ability to self-heal the applications and stuff. And it will hopefully be like, oh, and by the way, did you realize that under the hood, it is Kubernetes that's going on there, so that organizations and certainly application development teams can just write their applications. This cloud native way becomes the way to write them. And they're not thinking about like, how do I hook it into Kubernetes? And there's not like necessarily this big infrastructure team that's like, we're constantly managing the Kubernetes layer. I feel like, and we're really not there yet, but we are aiming to a point where maybe it's a spin on the, Kubernetes needs to be boring, as in, it's just there and it just works and it's maybe installed as part of something else or what have you. I think as well, though, aside from the infrastructure, I know with a lot of enterprise organizations, especially like the more those that like slower to adopt new technologies, they're always asking like, what's my biggest challenges when I come to deploy it, and how do I have to retrain my teams, not from an infrastructure perspective, but like to think about how to develop and refactor those existing applications and new applications, because it is like there's an infrastructure side of it. You've got to be able to have like that high performance, highly available infrastructure layer that Kubernetes is a big part of. But then you've also got to be able to have your teams write the applications to fit that, because I know that Docker did this a while ago with the ability to, or like a service to port like your legacy monolithic applications in place and run them on Docker. And you got like some benefits doing that, but to get the full benefits, it is like really a rethink of how you do your applications. And that still seems hard to me. Certainly for enterprises, they're like, how do we do that? What do our application teams need to change in their mindsets, and change in the way that, you know, and what needs to change in the pipelines and things that they've got? And there's just seems to be a ton of complexity there as well.
Yeah, there's certainly plenty of complexity. Do you have a slide? You've taken over the questions, Nigel. Do you have a slide for the next question?
No. So what I was going to do was, if you had a question, I will just edit this slide on the go.
Cool.
And put in what the latest question is. If we don't have any new ones that come in, we've got some from Twitter.
We do already.
Say again?
We do already have new questions. We're not.
Yeah, let's have a new question then.
Hey,
to do that,
okay.
go on then. What is it? You shout it out and I'll type it up.
Okay. So Tom Kivlin asked on the Slack, what sort of change or feature would trigger a 2.0 release for Kubernetes?
Oh, okay. I'm writing this up right now.
What sort of change or feature would trigger a 2.0 release of Kubernetes?
Right, so excuse any potential typos that come here, right? Whoops, wrong slide.
Yeah, we've already got one on that slide.
Yeah. You've, okay. See, I'm not sure how well this is going to work. We're about to find out. Here we go. Right, if I go present again, hopefully everybody should see the next. So what kind of change or feature would trigger a 2.0 release? So I'm going to give my like really easy answer here, right? Like hopefully nothing ever, just because it sounds like such a, well, look, a move to and I'm assuming we're talking like, instead of going Kubernetes 1.22, 1.23, we decide at some point this is going to be Kubernetes 2.0. And that sounds like such a horrific, breaks everything type release that I don't think anybody wants it. And it's a funny thing. Look, I could be totally wrong, and I'm really keen on your thoughts on this as well, Adrian, but I think traditionally for me, when you've looked at things like Linux and Windows and stuff like that, and they do these almost huge breaking releases where it's a big, I know it's not quite the same, right? But going from whatever it was, Windows Vista to Windows 8 or Windows 10 or whatever, I could never find the control panel or the printer and things like that. And it's a bit of a pain, okay? But when you're running line of business applications on such an important platform as Kubernetes is becoming, if your applications suddenly can't find the control panel or the printer, you know what I mean, right? The APIs and things that have changed so much that you have a hell of a lot of work to put in to make your applications work. I don't know what the appetite is for that. And I came into the world of containers and Kubernetes thinking myself, like, when will we get a 2.0? Surely we're not going to be at version 1.230 in like 10 years. But I kind of wonder whether we might, from like a main Kubernetes like release channel, things like, even just things like pods and deployments and stuff, going from a version 1 to a version 2 would be really hard. But at least in that, they could deprecate let's say Kubernetes 1.30, and I'm making this up, right? Has like something super core like pods or services go to, instead of being V1 API, go to V2, right? The V1 would be deprecated for like 1 million releases first because it's so core. So I think it's almost a mindset change to say that something as fundamental as this for like a Kubernetes 2.0, and look, I could look like a fool here, and we could get to Kubernetes 2.0 next year. And if that happens, then I'll be trawling the internet and deleting every comment of me saying this. But I just almost feel like that's just not the way we'll go going forward. And feel free to disagree with me. I don't know what you think on that.
Yeah, I think that's a pretty reasonable point of view. There's a couple of things there. One, I'd have to ask a Kubernetes core developer exactly what the different releases actually signify. But at the same time, we do want to allow space for innovation and change. I I suspect like Kubernetes 2.0 would, might end up being a completely different product. Yeah.
Can you imagine? See, I do think there is space for that innovation and new things with the way that individual APIs within Kubernetes, like pods or services or the gateway API or things like that, they can iterate almost at their own cadence. And we know that within Kubernetes, you can run different versions of the API for different features. Like we had, like, for instance, I think deployments is a really common one as well. That's been V1 for a while, but it was like V1, Beta 1, and V1, Beta 2 were all still available within Kubernetes for like the longest time. So it's a great question. I still hold to hopefully nothing will ever take us to that point, but we'll see. If we could make it smooth, then I wouldn't be worried.
Cool. Okay, I've got another great question. It kind of follows on. So on Twitter, Ramprasad asked, will serverless replace Kubernetes?
Oh, right. Okay. So will serverless replace Kubernetes?
Maybe you start typing.
You start giving your
I can
answer
give an
on it.
answer, but I don't, it's really about your session. But what I would say is the first thing I point out is that it's quite reasonably common to run sort of serverless on top of Kubernetes.
Yeah.
So I see Kubernetes future being sort of as an infrastructure layer, and quite often running serverless workloads, especially for on-prem customers.
Yeah, I feel like almost, and I don't want to put words in Ramprasad's mouth here, but it feels like the question is more like, will serverless replace containers? Because I think I would agree with you from a Kubernetes perspective. Kubernetes, for the most part, manages containers, but there are ways to have it manage serverless workloads and virtual machine workloads and things like that. So I certainly, I don't see Kubernetes going away. And I think that's important for anybody that is looking to get started. Like as an individual, if you're thinking, is Kubernetes a good thing for me to bet my career on? As in, like, do I want to put in the time and potentially money to invest in Kubernetes skills? I think you're fairly safe there because there's such a strong ecosystem and all of the major cloud providers and people out there, the major tech companies are either offering Kubernetes services or are building tools that hook into Kubernetes. So the future is bright if it's, if we're talking about Kubernetes, but also for an organization as well. If an organization is saying we're wanting to make a technology bet at the infrastructure layer that we don't want to have to invest in today and rip out or replace in 2 years' time, we want this to have a strong roadmap. I do feel like Kubernetes has a super strong roadmap. So with this being like a getting started with Kubernetes session, if you're an individual or an organization and you're sort of umming and ahhing and being like, oh, shouldn't we go down the Kubernetes route? Of course, this is just my opinion, and your career and your business units and stuff way better than I do, but I do feel like Kubernetes is a solid choice. So I don't feel like serverless or anything else is going to wipe it away. I would go with what you said, really, Adrian, that Kubernetes is going to manage serverless workloads rather than serverless workloads replace Kubernetes. Now, will serverless workloads replace containers? My opinion on that also is no. And I feel super confident on that in as much as like we've still got mainframes out there. Like I spent a lot of time working in retail banking in the UK, and no joke, millions and millions of pounds or euros or dollars were spent every year on mainframe infrastructure, and not rusty old stuff with dust on the top of it, like brand new mainframes at the core of a lot of businesses with open systems around that and virtual machines and now containers and stuff. So I would say that even if the question is, will serverless replace containers? For me, it's no. They'll be shoulder to shoulder in just about every IT estate in the next 2, 3, 4, 5, 10 years, in my opinion.
Okay, actually, that brings, we don't think we did a slide for this, but related to what you were just saying there, how do you keep your skills up to date when Kubernetes is so complex and has so many releases? And I realize part of the answer is buy your book, but.
Yeah. 1 second. I'm just going to.
No, I don't know if we did a slide for that one.
No, just in case anybody's joining late.
Okay, go for it. The reason that I don't the slide is just because I don't have a good answer.
All right. Okay. Do you know what? Yeah. Look, I say this all the time because, look, I teach people Kubernetes and containers. And I do very much feel like, and I apologize for anybody who's heard me say this before, but I feel like we live in a golden age of learning new technologies. Like if I wind the clock back to when I was doing my MCSE in Windows NT 4, or even like my NetWare certification that I never got, but I was working towards years ago, I had to go to my boss and beg him to loan me a spare PC from work. And the PC, it was one of these massive old compact things that had a monitor that you almost needed a forklift truck to lift. And I was installing, I think, Windows NT 4, I might even have had it on floppy disks as well, but certainly either floppy disks or CDs. And anytime you would break anything, and breaking stuff is a great way to learn, right? It would be like, let's rebuild the NT domain. And that's like 4 hours of waiting for Windows to build. We're not there anymore. We're like, if you want to learn Kubernetes, you can install Minikube or Docker Desktop or a ton of different things on your laptop. Boom, like that. You've got, okay, it might not be a production grade Kubernetes cluster, but I'd go so far as to say, even with something like K3D or K3S, you almost can, because you can have like a multi-node Kubernetes cluster on your laptop that you can trash and rebuild in like a couple of minutes. And even if that's a bit too hard for you, you can go to like most of the major cloud providers and get some free credit in most places to spin up Kubernetes on their infrastructure and just play about with it till your heart's content. And then, of course, like, okay, so I think that my Kubernetes book back in 2016 or 17 was the first one, but there's flipping loads, excuse me, but there's loads now. Like you're almost spoiled for choice with books and with video training courses, with hands-on platforms that will walk you through how to do it. It's like today, and I mean this respectfully, okay, but there are no longer any excuses to not learn something like Kubernetes. It's not hard. You don't have, like that PC that I borrowed from my boss. Literally, I put it on a makeshift table in the corner of our bedroom when I was first married and had a really tiny house. And when you turned it on, the fans were really loud. My wife was like, really, do we need that? No, but the world's not like that anymore. It's so easy to actually get your hands on, and the resources are out there. And you come to events like this and you do Twitter and stuff like that. You ask people, I think you get answers. So I think Kubernetes is hard to learn, but the tools to help you learn it have never been better than they are now.
Yeah, I fully agree. I think that's a great answer. It actually leads on to a question from Bruno Gabriel da Silva, and I think we can keep the slide so it's still in context.
Okay.
And he says, what's the difference for you learning from a book or video classes? I maybe go first. Yeah, I would say it's different strokes for different folks.
Yeah.
Like I would have said, like Bruno, that I get more from books most of the time, especially for going deeper reference. But I find myself watching videos quite a lot recently, and I've really enjoyed like Clustered by Raw Code and so on, and I've definitely learned stuff from that. I don't know what your take is.
Yeah, so I definitely think, I think the combination of the two is the best, and I'm really not just saying that because I offer both. But I feel I like a book, and I like a paperback book versus something like an ebook or a Kindle. It might be just because of the age I grew up in, but I feel like a book I can make notes and I can scribble and I can have it on the desk there, and I can easily flip to a page and find, some notes that I made. And I can't do that with a video course.
Yeah.
So here's what I recommend to people. So I recommend both, because I think multiple ways of learning something, hearing something and reading it yourself, one cements or concretes the other. But people that are studying for an exam, this is the advice I give them, right? Is I say, take the book, okay? Read the book, make your notes in it, and follow along with the examples. Super important to follow along with the examples, especially if you're going to take like a practical exam. But then maybe the day or two before the exam, then watch the video course that goes with the book or is similar to it as like almost a refresher, a reminder, because I feel like I can watch a video course and really enjoy it, and the humor, and it feels like it's more interactive, and it's a different way for me as a video course creator to be able to present content. But when I watch video courses, I quite often feel that like I almost can't remember the stuff afterwards. And it's harder to go back than it is in a book and just read a quick paragraph that I made a note against. So yeah, I would advise both. But if you are preparing for an exam, book and follow the examples with your hands on, and then either an audio version of the book or a video course as like a refresher. Because taking exams, and I know the question wasn't necessarily about that, but when you take an exam, I'm not a fan of like really working hard the night before and in the car that you got an extra 5 minutes before I have to go into the testing center, or it's in your room now at home, isn't it? I'm more of like, take a chill and get yourself relaxed before it. And that relaxation, perfect way to do it is just stick the video course on. Don't stress yourself about trying to remember. Just let it play, enjoy it, have a bit of fun.
Cool. Okay, I think we should get back to an actual Kubernetes question. We're starting to run out of time now.
All right.
But Tim Bannister asked on the Kubernetes Slack, or the Cncf Slack, what things outside of Kubernetes proper need to get better in order to make the overall container orchestration story more effective?
Right, so I've kind of summarized the question because that's far too much for me to type.
Yeah.
But let me just, and please tell me, right, if you don't think I'm answering to the question. So I've put what things outside of Kubernetes need to get better. Okay, so I think, right, the number one thing outside of Kubernetes on a technology perspective that you need to go into production is a service mesh. And I'm not necessarily saying they all need to get better. Well, look, that they do it, and everything. Look, even if they're great, we always want to be striving towards getting better, don't we? So I would say you in production need a service mesh, and some of the service meshes in particular need to get better. But again, it's really difficult. Like we talked about Kubernetes before, these service meshes are trying to do a lot of things for us, and you don't just build that overnight and make it simple overnight. So I'm not criticizing any of the service mesh communities or vendors or anything like that. But I think service mesh is important and it needs to get better. If I could take like a non-technical one as well, but it is coming back to something we suggested before, is that I feel like organizations structurally need to get better. So to be able to go cloud native, you really need to rethink your organizational structure, the way you build teams of developers and the way that they interface with each other and the way that they interface with the infrastructure teams and other people like that. That really is like a key thing, because it's not just about technology. It's about process and things as well. So my two things will be service mesh and then like organizational structures. And don't get me wrong, like there's a list that we could go on for forever as well.
Yeah, my boss would love to hear you saying that about organizational structure, because that's absolutely what we sort of focus on at Container Solutions. But what I would say is I would actually tie it into another question we got asked on Twitter, which we didn't want to answer because it's too complicated.
Oh yeah.
It's like Owen Hollins asked, how do you maintain and upgrade your clusters? And also it's scaling up and down. And I think that's something that, we still need to work on. I think Getups is probably part of an answer there, at least.
Possibly. Yeah. I really don't feel like we're there for that. And I'll take two angles on that, and they may be cheap angles. Okay. The first one is I do feel if you go the cloud route, like a managed or a hosted Kubernetes service, like EKS or GKE or Linode Kubernetes Engine, whatever. And I'm not speaking to particular hosted services here, right? But I feel like the cloud vendors almost have those kernel engineers on staff that do that hard work for you. I know, for instance, with GKE, like in the early days, you didn't really have much of a choice with regards to upgrades, whereas at least now that they offer you can go on the rapid channel if you want to, or you can go on the more stable channel. So they're giving you more dials and knobs and buttons to press and stuff to help you with that, and they really make it quite a lot simpler. I think the other thing is that I feel like, and I don't want to speak out of place here because I know that the maintainers and the community do an incredible job. But I feel like moving from 4 releases a year to 3 is a step in the right direction. It makes it easier for people, you know, when there's not 4 new releases a year, elongating the support window for older releases as well. But I would love to see us move towards something for the enterprise in particular, like a long-term stable, like we have with Ubuntu and plenty of other products actually, where there's like a particular release that we target, that we say this one is going to be supported by the community, and vendors will pick up additional support as well for a longer period of time, and we will provide a smoother path to get to the next long-term stable release for customers. So from a customer perspective, I think like the easy option at the moment, or the easiest option at the moment, is hosted Kubernetes. And I really hope that the community going forward will make strides so that, you know, even if you're doing your own on-premises stuff, DIY Kubernetes, that the process gets easier.
Yeah, I think that's an excellent answer. I think we need to hand back now. Am I right?
Yeah.
Danny? I think we're out of time, but I can't keep going. More questions.
No, that's okay. I think we're doing okay on time. I actually, your point about self-learning actually really resonated with me, Nigel, because obviously that's kind of, I've spent like over a decade hunting for information online and moving in and out of IRC channels very early on. And I know people before me probably had to go fishing on Usenet for information around technology. So it definitely has gotten a lot easier. But I think the tools are there. It's also a lot more noisy though as well.
Yeah.
So it's also much harder to get people's attention. But I thought, yeah, really enjoyed your Ask Nigel Anything. So that was quite good. I guess typically we'd use this time to ask questions, but the whole point of your the whole point of your session was asking questions. So I think we have another 4 or 5 minutes before our next speaker joins.
Okay.
Oh, okay.
I have a question that probably is a bit too big to answer, so you might want to take this to Slack or something. Whoa. But you mentioned that service meshes are essential going into production. That one of the things you need. Maybe not essential. That's not the word you used. Sorry, you said that service meshes are something you need to go into production, and that's just an interesting thought, because I see people still playing with service meshes, but lots of people already in production.
Yeah. So let me take that for a couple of minutes, right? And I don't know what Adrian's thoughts are as well. So I feel like what a lot of service meshes bring, a production installation of Kubernetes is almost crying out for it. And if you can do it at day one, then all the better for you. Excuse me. I just think like, you know, the whole sort of microservices design for applications where all of your different application features are now communicating over a network. And I'm picking some low-hanging fruit here, right? You know, they're not communicating over shared memory on a single host anymore. It's much more dangerous now that all that chat is going over the network. So the ability to almost have visibility into your network, the ability to sort of have your network almost learn. Maybe I'm getting towards Ebpf here a little bit more, but also that ability to, at the infrastructure layer, encrypt communication from pod to pod or container to container, however you want to think about it, and not have to ask your application developers to say, we need you in like your containers that we're asking you to build and make them single purpose. Could you actually just go and put this, you know, encryption, decryption stuff in there as well, please? I really feel like, you know, the fact that a service mesh will offer all of those things and more as you go to like proper production. And my view of it may be tainted, but I'm not a fan of that word actually, because I spent so much time in retail banking where they're like so obsessed about like security and what have you. So I don't see many of my prior organizations wanting to dive into something like containers and Kubernetes in a distributed microservices architecture without the features that a service mesh brings.
No, makes sense. Thank you.
Cool. So thank you very much, Nigel, and thanks, Adrian, for moderating as well. That was great. Our next talk is Rory McCune, and he's going to be talking about getting started with Kubernetes security. So over to you, Rory.
Everyone, how's it going? Yeah, let me just get my slides up. Slides. Okay, awesome. Hopefully everyone can see the slides. Yeah, so the goal of this talk, or the reason I ended up giving this talk, was every time I do a talk about Kubernetes security or container security, one of the questions I always get asked is, what's the one thing I can do for container security or for Kubernetes security? And I think that's quite a kind of common theme, because a lot of companies, they're getting started with containers, they're getting started with Kubernetes, and they don't necessarily have a lot of time to think about the security side of things. So where do you start? And so that's the goal of this talk. What I want to do is go through some ideas about how you can think about security, some of the things you can think about, how you can think where do you need to spend focus your time, and then talk a bit about some quick wins, some things you can do quickly and easily to improve your cluster security. So before we get started, just very brief about me. My background is information and IT security, working in financial services, consulting, in a number of places. Last 10 years, I've been a pen tester, so kind of basically breaking into systems. In the last 5 of those, most of those systems were Docker-based or Kubernetes-based, lots of container work. These days, I am a cloud-native security advocate for Aqua, and that basically means that my job is, well, doing things like this, right? Trying to help the overall position of cloud-native container Kubernetes security. One of the things I do as part of that is I'm an author of the CIS benchmarks for Docker and Kubernetes, which are a useful resource for hardening both of those platforms. I'm also a member of Kubernetes SIG security, and also the only unofficial Kubernetes SIG, I think, to have done a keynote at KubeCon, which is SIG Honk. And we kind of focus on like hacking and playing around with breaking into clusters. As you can see from the sticker on the right-hand side, you might guess that I'm based in the Scottish Highlands, as that's a Highland coup breaking out of a container. And I stay here, which is Loch Goilhead in the West Scottish Highlands, just west of Loch Lomond a little bit, which, as you can see on a nice day, looks really lovely. And actually this summer, we've had loads of nice days. I think we sent our rain down south this year, because usually it rains here pretty much all summer, but actually we've had lots of nice days. So nice place to visit if you get a chance. Anyway, let's get started on the talk. The first thing that I wanted to talk about, or the first thing I think you need to think about when you are getting started with Kubernetes security, is how much resources do you have to do this, right? Do you have like this, you've got like a squad of people who you can dedicate to doing all the different activities you might want to do. You might want to do image management and container security. You might want to do service mesh security. You might want to do hardening. In an ideal world, you would have resources that look like this. You'd have lots of people to do all the activities you need. But let's be realistic. For most people, they've got a lot of work on. They've got a lot of different things to think about. And the primary focus is going to be making things work, right? It's going to be getting your cluster working, getting your applications working, and keeping them working. So when it comes to security, your resources probably look a bit more like this, right? You may have, if you're lucky, a full dedicated person. You may just have a bit of someone else's time. When they've got something running, they may have a bit of time to work on hardening. It may be something people have to work around as part of their other responsibilities. And this is why it's really important to think about where you get started and targeting your resources well. Because if you haven't got a lot of people to spend, you don't want to spend that little time that you've got doing things that don't really improve matters. So how do you go about doing this? This is what I want to talk about is how can you actually do that? How can you think about this, try and make sure you're targeting those limited resources in the right place? So here's how I would do it, or how I do it. First thing you need to think about is your threat model. Now, threat modeling is, there's whole books written about threat modeling, but really when you're getting started, you can think about it like this. A threat model is who is going to attack me? Who is going to attack my Kubernetes clusters? Who is going to attack my applications running in those clusters? Because once you think about who is going to attack you, and you think about how they might do that, it gives you an idea of where you need to start on the defensive side. With Kubernetes clusters, I tend to think of 3 threat models. So you can just think of which of these 3 apply to you. The first one is, if your clusters are on the internet, or the applications that they host are on the internet, then you need to worry about internet-based attackers. There are people on the internet scanning around the internet looking for vulnerable systems all the time, using automated scans or manual attacks. If you're on the internet, you need to worry about them. There was some research done by we've got kind of a threat research team called Nautilus, and their latest statistics were that from the time a vulnerable system, in their case a Docker daemon, was put on the internet, to the median time to attack is 50 minutes, so less than an hour. So if you put a vulnerable system on the internet, then you have about an hour before it's likely that someone's going to find it and try and compromise it. So that's the first threat model, and most clusters probably have to worry about that. The second one is compromised containers, right? If you've got, say, 10 or 20 applications running in a cluster, statistically, it's likely one of them is going to have a vulnerability, right? Applications have vulnerabilities. And it can get exploited. And when it gets exploited, your attacker is going to land in a container inside the cluster. So if you've got the kind of setup, you need to worry about the sort of things you would do to protect against someone once they've landed in a container from going around and trying to compromise the cluster. The third one is compromised user credentials. So if you've got a lot of users in your system, or if some clusters are even worried about like users not being able to get too much access, then you might need to think about that as well. So you might need to think, well, if I've got a lot of users, how do I lock them down? How do I stop them from getting more access than they should have? But in some cases, you might not need to worry about that. So if you have, for example, a cluster which feeds all its containers through a CI/CD pipeline, and you have a single user, then you probably don't need to spend as much time on those kind of attacks. I'm not saying in an ideal world you do nothing, but realistically, when you have that small quantity of resources, you don't start there. And with the other one, with compromised containers, if you have no externally facing applications in your cluster, maybe they're all internal batch processing applications. Again, maybe you don't have to worry as much about compromised container attacks, and you can focus purely on that kind of external hardening piece. So thinking about threat modeling is useful, just in that basic way of what do I need to worry about, to give you an idea of where to start. The other thing when you're thinking about where to start is you need to think, where can someone attack me? And this gets called attack surface. Basically, that means what is exposed that the people I'm worried about attacking can get to and can try and compromise. So if your clusters are on the internet, they are obviously part of your attack surface. If your applications are on the internet, they're also part of your attack surface. But there's other things that might be less obvious that can be part of your attack surface, which would be things like container registries. If you have a container registry, you're using Docker Hub for your production images, your Docker Hub accounts are now part of your attack surface. If an attacker gets access to your Docker Hub credentials, they can push malicious images, which are then pulled down into your production clusters. Your CI/CD systems, you're using a cloud-based CI/CD system that's on the internet, that is part of your attack surface. We know that attackers will attack CI/CD systems. We know that they try to compromise them. If you use those, then you need to concern yourselves with both how you get access to those CI/CD systems, but also the security of those platforms themselves, because they've got security problems too. So attack surface is an important one. So that's who's going to attack me. That's where they're going to attack me. Now, how do you think about how do I want to take that information and turn it into where do I start? And for this, this is possibly the most important slide in the presentation. It may not look like that, but I think it is. The way I would suggest you want to take that information that you've thought about, who's attacking me, where they're attacking me, and think, where do I start now? You're looking to improve your mess up tolerance, MUT, mess up tolerance. The idea here is mistakes happen, right? Configuration errors happen, user error happens, CVEs in code happen. These are inevitable. What you want to try and avoid is a situation where a single mistake, like a single lost set of lost credentials, a single bug in a program, a single vulnerability, can cause a security incident in your environment. That's why I'd call a mess up tolerance of 1, because if you have a single mess up, you have a bad security incident. What you want to try and do is get to the point where it would require 2, 3, 4 incidents all to happen in the same area for you to have that security incident. I'll give you a worked example, just try and make that a bit more real. Say you have a Kubernetes cluster, right? And you have it on the internet, right? The API server is exposed to the internet. Now that is a moderately common configuration. There's several 100,000 Kubernetes clusters sitting live on the internet at any given point in time. And there's some search engines you can go to look around them all if you want to. And then say you have anonymous authentication turned on your API server. Again, this is a moderately common configuration. Indeed, it's a default configuration for some cloud cluster providers. So in that situation, you've got anonymous auth on, API server on the internet. If you make one RBAC mistake, so say someone applies a Kubernetes manifest to that cluster that says bind cluster admin to the system unauthenticated group. Now that's a mistake, that's a bad mistake, but it's a single mistake. And if you have that configuration and then you bind that bad manifest, your cluster is going to have a bad time, right? The attackers will find it quickly, they will compromise that cluster. Now, how would you improve that? Well, if you took anonymous authentication off, say your cluster doesn't need anonymous authentication to be enabled, you've got other ways of doing things like metrics. At that point, you now have a mess up tolerance of 2, because someone's going to need a set of credentials and they're going to need the rights to do it. So you now have 2 things that probably have to go wrong at the same time for you to have that security incident. Then say, for example, you take your API server off the internet. You don't have it exposed to anyone. Either maybe you limit the source ranges that can get to it, or you put it behind a VPN or an SSH bastion, or your cloud's remote access service, which most clouds have got these days. You've now got a mess up tolerance of 3, because someone's going to have to compromise your bastion or your remote access service. They're going to have to get valid credentials for your Kubernetes cluster, and they're going to then have to get the rights to actually deploy whatever it is that they want to do. So just those simple steps can take you away from a situation where a single vulnerability in the Kubernetes API server, for example, there could be a CVE tomorrow in the Kubernetes API server. If your clusters are sitting there on the internet, you might have a mess up tolerance of 1, and that could obviously be very bad. So for my money, if you're getting started, that's a great approach. Think about the places where 1 mistake could give you a security incident and try and start there. Start trying to get those numbers up. You just even get up to 2. Yeah, get all the places where it's 1, try and make it 2. So that's one way of doing it. So with Kubernetes though, how can we do that? Where are the things that we can apply to make that happen? First thing to do is to think, can we reduce our attack surface? And then when I originally showed attack surface, I had the big, huge castle with all the different ways in, loads of windows, loads of doors. Can we reduce that? When you reduce your attack surface, you're lowering the number of places where you have to spend those limited resources, right? So you don't have a huge number of resources. Very few companies do. You're trying to say, where can I focus? If I have 500 points of attack, I have 500 places I have to worry about, 500 places to spread my resources across. If I have 5, I can focus all that same effort in 5 places. Therefore, I can put more effort per place. Lower the attack surface, the better you can focus your security efforts. With your limited resources, the more chance you'll have of avoiding something bad happening. How can we do that though? Well, let's talk about some of the real kind of things you can do for that. We'll start off with quick wins. What are the quick wins? The things, those like you want one thing to do. What can you do as the one thing? Don't put your clusters on the internet. Some people who are watching this may be thinking, well, that's obvious. Why would I put my Kubernetes API server on the internet? Other people will be thinking, all my API servers are on the internet. As I said, there's about 400,000. It's something around that mark. I haven't checked in the last couple of weeks. Kubernetes API servers directly connected to the internet. You can always spot an API server based on the TLS certificates that it presents. There's also tens of thousands of clusters online with anonymous authentication enabled, because you can go and look at the version endpoint and find out what version of Kubernetes they're running. If your cluster API server is on the internet, you potentially have always got a mess up tolerance of 1, because a 0-day attack, an unpatched vulnerability in the Kubernetes API server, and your cluster could be compromised. Getting that off the internet, if you don't need it, you can limit IP address ranges if you need systems to be able to talk to it. You can put it behind a bastion, a VPN server. There's options you've got there. But if you can get that off the internet, you're reducing your attack surface for sure, and you're getting their mess up tolerance away from being 1. That's the first thing I think that's worth doing if you can. New clusters up's easier. Existing clusters, you might need to look at what might be using that and rework it. Second one, use managed Kubernetes if you can. When you use a managed service, so like something like GKE, AKS, EKS, you get this shared responsibility model where the cloud provider will take on some of the responsibilities for security. So with managed Kubernetes, that typically means that you no longer have to worry about those control plane nodes. You don't need to worry about patching your control plane either, because both of those things should be done for you by the cloud service provider. So that's reducing your attack surface because it means someone else has to manage that. Now, obviously, you're trusting that they will handle that, but it means it's something else you don't have to worry about. You don't have to think about, right, how have I hardened my API server nodes? How have I managed to patch the API server, et cetera, et cetera. You can let them handle that. So if you can use managed Kubernetes, you can focus on other areas that aren't, they're now handled for you by the cloud provider. So that's another one. Don't mount service account tokens unless required. This is when I look at Kubernetes defaults and I look at kind of the security defaults, this is what I would love to have changed. By default, Kubernetes will mount a service account token into every pod that is created in a cluster. The vast majority of application workloads don't need to talk to the Kubernetes API server and therefore probably don't need a service account token. Therefore, you can remove it. So you can remove it at the pod level. You can tell the service account not to mount the service account token by default, and then only mount it where specifically required. And you say, well, by default, it doesn't have a lot of rights, and that is true. But I've seen third-party products for Kubernetes that I saw one, for example, that bound, as part of its installation mechanism, it bound the default service account token in the default namespace to cluster admin. That means that any pod that was in that namespace and used the default service account token had cluster admin automatically, and any person who could create a pod in the default namespace got cluster admin for their workloads. Mess up tolerance of 1 again. If you don't have that service account token and you apply that manifest, you are not going to have as bad a time of it. It's less likely that someone will be able to compromise that. It also gives you time to notice that's happened and try and go, hey, you didn't mean to do that. That's a terrible idea. But don't mount service account tokens. That one should be fairly easy. Unless your workloads are using it, which you would probably know about, you can, get rid of that. So there's also some things which are high impact but harder. These are things which aren't as easy to do, but which, if you can do them, will have a big impact on in this case, your attack surface. Default deny network policies. By default, every Kubernetes workload in a cluster can talk across the container network to every other workload. This means that if someone can compromise one container, they can scan the whole container network. So when I was a pen tester and I did a compromised container assessment, so where I start with a compromised container, my very first thing to do is install a port scanning tool, scan around the entire container network, looking for other services to attack. And what I typically found was that people would assume that things installed inside the container network were on a trusted environment, and they maybe didn't have authentication turned on by default. So that gave me other things to go and attack. If you can turn on a default deny network policies, this is harder because it means when you're developing applications, you need to think, what other services does this application communicate to? And then you need to write network policies that imply that make that the case, so that you know that when you deploy it, you'll get the network policies you need to talk to other systems. So it is harder to do, but it does have a big security benefit if you're worried about compromised containers. Again, if you're not worried about that scenario, you maybe don't need to do this as much or as early in your process. But if you do, it's a good change to make. So in addition to reducing the attack surface, we can also harden things up. We can improve on the security defaults that are given to us by our container runtimes and by Kubernetes in ways that will essentially make it harder for attackers, will improve our mess up tolerance, and kind of make it more likely our clusters will be secure from day to day. Again, let's look at some quick wins. Let's look at things you can do easily that shouldn't have any impact on your working practices or your existing clusters or applications, but will improve things. First thing to talk about is security context and workloads. This is as an application, if you're an application developer or you're an application owner, one of the best things you can do is set security contexts on your workloads because you're essentially making it easier for you. You're reducing the privileges given to the application when it's deployed. And you are helping also, if you then go on to do things like admission control, you're making it easier for that to happen because the applications already have the security settings they need in place. So everyone's clear about what's required for this application. A couple of easy ones to set. Security context, privileged false. Privileged containers are very dangerous. You should never use privileged containers unless you absolutely have to. Explicitly setting this as false just makes it clear that you don't need that and you don't want it. It means if you're using infrastructure as code scanning tools, that you can clearly see which ones have got it, which ones don't. The default is that it shouldn't be on, so it's not as bad if you don't have it set, but I always recommend as a nice, easy, if you're doing templates for your application manifests, put in that security context, privileged false. Makes it really clear to everyone that you don't need privileged containers. Another one to set that should be relatively easy, relatively low risk, is allow privilege escalation false. This one's not on by default, so this is worth setting. What this basically says is, if I start my container as a non-root user, don't allow it to get more privileges once it's running. Don't allow it, for example, to sudo up to root. That should be fairly safe. I don't think I've ever seen an application that starts with low privilege and then tries to get more privilege inside the container. I've seen applications that do the reverse. So maybe they start as a privileged user and then drop to an ordinary user, like I think Nginx does that. But I've never seen the reverse. So this should be relatively safe, shouldn't be a problem. If you put this in your application manifest templates, you have a setting which should improve your security. In this section, there's quite a few things that are harder, but high impact. Things that are, if you have that extra resource, maybe you've got some additional time, or you're planning something out for the future, definitely worth considering. Security context and workloads. Previously, we talked a little bit about some easy settings, some things that aren't super complicated, shouldn't be impactful. There are other things you can set which do require more effort, but are significant benefits. Don't run as root. Containers running as root is not a great default from a security standpoint, but they do. So you need to do the work for this one. So essentially, you need to work with, when you're developing your container images, to have them run as a non-root user. So setting a user, making sure that the application can build and run okay when it's not root. When you've done that, then you can set these settings in security context to say what user ID and what group they're going to run as. Don't explicitly use that 10,001. That's just one I picked out as an example. The reason this is important is if you run your containers as root, there is more of a chance of a breakout. Whilst your container runtime, like Docker, will constrain root, so it's not completely unconstrained, there have been several CVEs now where the first line of the CVE is this only works if the container runs as root, right? So it will reduce the risk. If there's a CVE and you've got that mess up tolerance, you say, well, if I'm not running any of my containers as root, this is less likely that this can ever be exploited. In some cases, it actually might not be possible to exploit. So this is a good hardening setting, but it does require more work because you have to look at it for each application and make sure that it can run as a non-root user. Read-only root file system, setting it to true in the security context. So here, containers are meant to be ephemeral, right? Containers are not meant to store state inside the running container. They're not meant to store any persistent data. So you should be able to set the read-only root, the root file system to read-only. You do need a bit of work because if your container needs to, for example, write temp files or log files, you need to make sure those are mounted in with like an empty dir volume. But fundamentally, this one will frustrate attackers. What an attacker will do typically when they compromise a container is they will put their tools, some sort of binary, some sort of malware into the container so that they can then carry on doing what they want. If they try to do that and it fails because you have a read-only root file system, it will either slow them down while they search around looking for the writable file path, or it might stop them. If it's an automated scanner, it tries to drop the tool, it doesn't work, the scanner moves on to the next host. So you can actually save you from attack setting read-only root file system. But again, does require a bit of work. Last one, cap drop all. Essentially, whenever you run a container, Docker or the container runtime will give it certain capabilities, which are parts of root's privileges. If your applications don't need those, you can drop them all in security context. Say drop all, don't give me any of these rights that I don't need. Docker chooses like a kind of what they felt, and they're probably right, was a sane default that would work for everyone. But a lot of applications, especially if you're not running as root, don't need any capabilities. Also, until recently, you might have needed capabilities to do things like bind low ports. So to bind like port 80, you had to have capnet bind. You don't anymore because in Docker, it sets a sysctl, which says you can bind unprivileged ports, low ports. And in Kubernetes 122 and above, you also have exposed that so you can set it in security context to say allow a non-root user to bind the low ports. And if you do that, then you can do this, get rid of all your capabilities, And it's going to make attackers' life, again, harder. If they land in a compromised container, they're going to have less chance of breaking out to the underlying machine and then giving you that bad security incident. But it does require a bit more work. You do have to think, do any of my containers expect to have a specific capability? Some other things, harder, but absolutely worth doing. Admission control. So security context is a voluntary mechanism. Every manifest can set it. If you're worried about either compromised user credentials, or you're worried about potentially you want to restrict the rights of your users to do specific things, you're going to need to mandate those controls. You can't rely on voluntary security context. And to do that, you need some form of admission control. In the past, we would have said pod security policy would have been the approach to take. As that's being deprecated, you should be looking now either to the new pod security admission controller, which is coming into beta in 1.23, or look at external ones like OPA or Kyverno, things like that. Use those to enforce your policies, and use those to enforce things like read-only root file systems, non-root users, and stuff like that. Again, this isn't the high impact, but harder, because fundamentally this is going to require you to probably go and get a piece of third-party software to implement it, make sure the rules are running right, make sure it doesn't impact your clusters. But if you have a multi-user cluster and you are worried about that threat model, you should do this. Again, if you're not worried about that threat model, you probably don't need to do this as early. Still ideally it would be good to have, but move it down the priority list a while. Least privilege RBAC. This is another one, only really matters if you've got, again, lots of users in your cluster and you're concerned about restricting their rights and making sure they can't do things they shouldn't be able to. This is quite difficult. And one of the reasons why, if someone says to me, I want a really tightly secured cluster, I say, well, try not to give people Kubernetes API access. Kubernetes RBAC has quite a lot of kind of like edge cases, things which are maybe not intuitive, but could cause security leaks. If I was giving simple advice about RBAC, the two things I would say is avoid cluster admin. Don't give people cluster admin. That's a terrible idea, because it allows them to do everything. And you probably didn't need them to do absolutely everything in your cluster. It also means that if you have a mistake, someone mistypes something, that they delete namespaces. Well, if you didn't give them the right to delete namespaces, they can't do that. The other thing I would say is try to avoid the built-in cluster rules, things like view and edit, because they're not very fine-grained, and they might give you access to things that you didn't expect them to give access to, and give rights you didn't expect. Always, when you're doing RBAC, try and think, what does this person actually need to do, or what does this service account actually need to do, and give it as fine-grained as possible. It is in the harder category because that does require work, but it's important if you're worried about the kind of user access side of things. Last one I would mention is internal container registry. When I was a pen tester, the finding I pretty much always gave in every single report was you are using images that are from random users on Docker Hub, right? You've downloaded not one of the official images, but some person's random image. Now, Docker Hub is entirely uncurated outside of the kind of official and vendor-based images. If you're pulling those images, they could be anything. And it also means that the third-party developer whose image you're pulling, their credential management is now part of your attack surface. Because if they lose their access to that account, their password gets stolen, their accounts get stolen, that's now your problem, because you're pulling their image into your cluster. The best way to get around that is to have an internally curated set of container images that you manage yourself in your own container registry. It doesn't need to necessarily be on-prem, obviously it's in the cloud, but something that you manage, that you control. And that gets away from that problem, because then what you can do is use admission control to say only allow images that come from our internal container registry. And that's going to essentially harden the setup quite a bit. But again, this is more work. You have to implement container registry, you have to manage access to it, you have to get all the tools and everything else set up for it. But for my money, that's somewhere that's worth looking into. So a couple more resources, a couple of tools which could be useful when you are doing your when you're doing this kind of work. First one is these are all open source tools. First one is Kubebench. Kubebench allows you to scan your clusters and compare them to the CIS Kubernetes benchmark. So just a quick way of saying, what settings do I have that I might want to look at? With the CIS benchmarks, one thing I would say is don't necessarily think I have to do everything on this benchmark, right? That's probably not necessarily, realistic, but it's definitely somewhere to start. The other tool is Trivy. You may know Trivy as a vulnerability scanning tool. So for scanning images for outdated software, It also does IAC scanning. So you can scan your Kubernetes manifests and you can come back with like things that are wrong, like you've got privilege set or you haven't dropped capabilities. And that's a tool that can be used on any machine. So it means that developers, when they're writing manifests, can scan their manifests against Trivy and say, what do I need to consider in terms of actually securing that down? And you can customize the policies as well. So, conclusion, think about your threat model. You're trying to think, you've got limited resources. Think about who is it you're worried about? Who do you think is going to attack you? And think about where can they attack you? Because that's where you need to focus your efforts. Improve your mess up tolerance. Best way to do this, try and improve your mess up tolerance. And there are some good quick wins to improve things. There are definitely some things you can do which will make things better. So that's all my slides. Hopefully that was useful. You can grab me on Twitter as @Racine or in email at that address there. And I'll be in Slack if there's any questions.
Thank you very much, Rory. That was very informative. Yeah, we actually have one question from Tim Bannister, which is, when Kubernetes adds support for enabling swap on nodes, how does that affect information security?
I'm not sure I can think of an immediate impact. I mean, there might be something with availability where it's going to improve things by, you have less likelihood of getting denial of service. That's the only one that kind of springs to mind. That's a tricky one. I'll maybe give that some thought.
There was one other question that I was thinking about, which is essentially I've heard lots about VM isolation with something like Kata containers and how that could have an impact on security. What's your opinion on that? What are your thoughts about a project like that?
If you're trying to do something like hard multi-tenancy, so I've got like untrusted workloads I'm running in containers, yes. Either something like gvisor or something like Kata containers or Firecracker. Linux, Docker, kind of CRI, it does a decent job of isolation, but I wouldn't rely on it against hostile tenants. And we've seen several CVEs. There's been CVEs in runC that have essentially allowed you to break out to the underlying host file system. It's quite a complex stack, and there's all these layers. You runC, containerd, then you've got Kubernetes, and they all need to line up their security primitives, which is a challenge because you've got different groups managing each of those. So if I was worried about, like, I've got hostile tenants, absolutely, I would be looking at either gvisor or Firecracker or Kata containers, for sure.
Cool. All right, any questions from you, Chris?
I just one question. You talked earlier about vulnerabilities and so on, and it seems like I think, as you said, almost all containers have some sort of vulnerability or will have some sort of vulnerability. Any advice on kind of anyone watching where to start with that? Do you threat model those vulnerabilities? How do you start categorizing them in what's priority to fix?
I think the thing I would say is the best thing people can do if they're getting started for container vulnerabilities is try not to install software you don't need in containers. The less software, the less vulnerabilities, the easier it'll be to pick ones. Then if you've got time and there's ones you can't easily patch, look for things that are remote exploitable. CVSS scores will have this thing about whether they can be exploited remotely. They're not always perfect because they don't know about containers when they write these scores. So it might not be applicable. So it is a bit tricky because you have to dive into each vulnerability. And that's fine if you've got 5, but if you've got 5,000, you're not going through each one and going to. That's why I always say the easiest thing, try and get rid of any software you don't need, because then you don't have this massive list to work from. And it's kind of that attack surface piece, get yourself down to a couple so you can actually focus in and go, what do I do here?
No, great advice. Thank you.
Great. Cool. So we're going to take a break for lunch now, and we will be back in just over an hour for the restart of track 2. So we'll see you then.
Have a good break. Thanks all.
Bye.
Right. Hi, everybody. I think we're maybe live now. Maybe, I hope you can see me. It's all a bit strange being backstage. But welcome back to KCD UK conference. I'm here with Danny, who are the co-hosts for the afternoon. Danny, I believe we possibly have, do we have messages from sponsors or anything we need to do?
I don't think so.
Okay, we'll come back to those later. So I just throw it Danny off the off the bus there. Okay, so what we do have for you this afternoon, coming up in a second, we're going to be talking to our charity partner. After that, we have a talk on Ebpf from one of our co-organizers, Josh Mickelson. Then we have seamless scaling of Kubernetes nodes from Marco. Yeah, and then some closing stuff after that. There is track 2. You can find a link to that, I hope, on YouTube. But the first thing we have is our charity partner. We have Phil Sturgeon from Protect Earth talking. So just before we go to that, I do want to say one of the best things about this conference, I think, is that we do have charity partners that mean quite a lot to us, and we're trying to raise as much money for them as we can. And I think both of them are very relevant to what we're doing in Cloud Native. So yeah, please take it away, Phil.
Great. Thanks, Adrian. Yeah, thanks for your support with this awesome charity. So if I can share my screen. There we go. Yeah, I just put together a few slides to show what we're up to at Protect Earth. So a little about us. As you may or may not know, the deforestation in the world every year is between 10 and 15 million hectares. A hectare is like a Olympic, like a running track, so it's quite big. It's also the size of the UK. Every 2 years, just gone forest cover, no more. So the UK has just 13% tree cover, which is way below the European average, which is like 37%. So there's not much. There's just not much around. And over the last year or two, I've kind of started feeling like things aren't okay. I'm sure a lot of you feel the same way. We all want to do something. So I was trying to figure out what could be done. Project Drawdown suggests that temperate forest restoration could be about 27, 28 gigatons of CO2 sequestered, which is actually twice the potential impact of electric cars, which are often hailed as the one and only savior of the world. So put together a crack squad. This is us working on our first project, planting 100 trees just to get things started. There's Ed with his hook slasher, and there's Andy planting some trees. And we partnered up with Ecology, who you might have heard of. They're like a monthly subscription service to basically do good around the world, and whether that's funding efficient cook stoves in Eritrea or biodigesters in Vietnam. They spread your monthly subscription around the world. And do good things with it. And one of those things is us. So as a charity, we do a few things. We work with landowners on existing that own their land, and we basically help them reforest that land or chunks of it for free. There's a bunch of different grants around that are really complicated to understand, and a lot of the time people want to reforest chunks of their farm or bits of their estate if they've got a huge garden. They just don't necessarily know how, and often the financial incentives are, well, we'll pay you back, but that's it. Or sometimes you only get like a 75% discount. So a lot of the time landowners are being expected to give up huge chunks of their land for absolutely nothing in return or at cost. So we help fix that a bit, help them work out all the grants, and we'll help with maintenance and thinning and watering, or work with local climate action groups to get that done so that we can reduce travel miles. There's loads of benefits for farmers. I won't go through them all, but it improves having a bunch of trees next to a field where there's crops will reduce wind damage, soil erosion, improve water, and reduce the need for fertilizers. There's a bunch of benefits. Specifically, shelter belts are fantastic at this. They can run along the edge like a big hedgerow, but there's often no government grants for these because they're too wide to be considered a hedgerow and too narrow to be considered a woodland. So we can help fund these shelter belts that otherwise wouldn't get done, and improve soil erosion, wind erosion. If you have cows in the field, it will actually reduce how much they shiver, which means you don't have to feed them as much, which means that's better for the environment anyway. But it also makes them happier. So if you do eat meat, then it apparently tastes better. So there's a bunch of different benefits. Agroforestry in general, we can do dot planting, cluster planting, putting them in a field. And so you can continue to use that field, or alley cropping, which is where you have rows of crops running through the field that you can also harvest. So you can get nuts and pears and apples without giving up too much land. We also do woodland creation. So here we are planting some of the 1,500 trees up near Middlesbrough. On the right, there's going to be a nice new lake and it meets a river at the back. This was a really fun project. We also work with, this was a fishing club who have permission to fish the edge of this riverbank, and it's slowly being eroded because all the trees have been removed and there's nothing there to hold the soil together. So we planted a whole bunch of trees, about 500 trees on this stretch of bank to try and keep the soil together. We get volunteers of all ages. This is the youngest one so far. I'm not sure how many they planted, but they're very cute. And we use local resources when we can. So here we are using horse manure for mulch for the trees. Not my favorite of jobs, but it's good for the environment. We plant trees all through winter. We planted 500 here in Llangrid Nodwells in Wales. And they are coming along nicely. They've already sprouted a lot. There's a bunch of oak, aspen, field maple, all sorts. And right now we're working on buying some land. So yeah, we need help doing that. And I'll go real fast on this stuff. We make sure that ecologists are in charge. So we're not planting in the stupid places like Nestle have done and wrecking wildflower meadows. We don't want to take agricultural land out of rotation. We make sure it's appropriate to plant. And we try and use good guards, not plastic, which just gets eaten anyway. So sorry, this is a bit more than I meant to talk about, but we use cardboard guards when possible. We've even got hemp mulch mats that biodegrade. So we've made a bit of software to help with all of this. A few of us are techies by heart. We've got a big old database of all of the trees that we planted. We take photographs of them all, store all the locations, and we use an iPhone app to do that. So yeah, we've planted 5,400 trees last season, and we're looking to plant 100,000 trees this season. And if you can help us do that, we really appreciate it. This conference is helping us out. And if any of you would also like to donate, just head over to protect.earth and give me a shout on Twitter or email me if you want to talk about anything. But yeah, thank you very much.
Thank you, Phil. That was great. I think we have 2 minutes before our next talk. Yeah, Danny, I think we have some messages this time.
Yeah, so just in this time, we just want to reiterate that we're grateful to our sponsors for the conference. So Sneak, Control Plane, JetStack, Sysdig, and Storage OS. And of course, Tramshed Tech, who's our technology sponsor. And also to our workshop sponsors, SUSE, Control Plane, Solo, and Container Solutions. And to our watch party sponsors, which I'm at the Manchester Watch Party right now, sponsored by Softiron. So thank you very much to our sponsors for providing financial support for the conference. And next up, we have our very own organizer, Josh Mickelson, who is going to be talking about eBPFing what? An introduction to eBPF.
Now can everybody hear me?
We can hear
there
you.
We go. It helps when you turn the microphone on. Brilliant. So let's share my screen. Right. So the title of my talk today is eBPFing what? An introduction to eBPF. My name is Josh Mickelson. I am a senior software engineer at Sneak. We are a cloud native security company focusing on container security, open source dependency security, and the like. So I'm going to talk today about eBPF and effectively what it is. It's a bit of a complicated topic, and so hopefully we'll get most of the way through this talk and have a little bit of time at the end for a bit of a demo. But there's a lot to cover. So the first question is, what is eBPF? Well, eBPF is a revolutionary technology with origins in the Linux kernel, blah, 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 blah. So obviously a very self-explanatory piece of technology, but really sort of begs the question, seriously, what is eBPF? Well, eBPF stands for the Extended Berkeley Packet Filter. The Berkeley Packet Filter was created as part of the Linux kernel a long time ago. Was originally used for mostly around networking. So picking up networking packets, detecting and actioning on certain things within the kernel from a networking point of view. But that's not really what BPF is anymore, or eBPF for that matter. eBPF is a technology now. We refer to it as technology, and specifically it's a sandbox bytecode and execution environment that lives within the Linux kernel. eBPF itself is a virtual machine that takes your bytecode, compiles it just in time to machine-specific machine code, and then executes it within the kernel. And we can use this to create software in the observability, networking, and security spaces. BPF programs, and I'm going to use BPF and eBPF kind of interchangeably throughout the talk. They both mean the same thing, really, when we talk about it these days. eBPF programs allow application developers to run custom code in the kernel to respond to events. And we can now do this without having to write things like kernel modules where you'd have to recompile your kernel, all this kind of stuff. We can load them in at runtime, and off we go. Programs for BPF are written in C, but it's a restricted version of C. They're compiled to bytecode in user space. The reason that we have to write them in a restricted version of C is because C itself, or at least within the context of the kernel, would lead to a potentially unsafe programming environment. So we're executing code in the kernel. We need to ensure some very strict safety of that code. And so things like loops, for example, are out. We can't have loops because we can't hold up the kernel anyway. We can't cause the machine to seize up, to stop working. And so we have to avoid writing our programs in a way that could lead to some sort of unsafe execution. Programs are loaded into the kernel via a system call, and that system call is the BPF system call, where they run through a verifier. The verifier does all those kinds of things. It's basically a static code analysis to ensure that the code that we're running isn't breaking any rules, basically. And then it's compiled into a machine-specific instruction set via the just-in-time compiler. eBPF maps are used to store and share data between the program in the kernel and the user space application. And we can also use maps to share data even between different eBPF programs, of which we can run multiple. So this is a bit of a diagram to show you sort of how it works. So we have an application. We do a bytecode compilation in user space and then load that bytecode into the kernel via the BPF system call. The kernel will run it through the verifier and then through the just-in-time compiler, load it into the BPF virtual machine where it will execute based on the hooks that you set within your code. And then when those events occur, they will be injected into the BPF virtual machine. Your code will run, you store that in a map, and then your application can access that map. So what are some of the events that we can attach to? And I'll go into this in a little bit more detail down the road, but we can do K probes, K rep probes, U probes, trace points, network events, and there's sort of a whole bunch more as well. There's trace events, perf events, stuff like that. The kernel provides us with helper functions that allow developers to call into the kernel itself to retrieve and store data, to do certain things that would be generally considered unsafe to do if you had direct access into the kernel. So we're going to take a moment to explore the eBPF ecosystem. I like this quote by Brendan Gregg. He's an engineer at Netflix. What is a quick and easy way to get a BPF performance win? And that is to think like a sysadmin and not like a programmer. The BPF ecosystem is huge and is growing rapidly at the moment. And there's a lot of amazing tools already out there that may already fill your needs without you having to go and write your own. So what are some basic tools? And basic in this particular case does not mean that they're simple or easy to make. What it means is that they're easy to use, really. You can, pull them from a repo or install them into your Linux machine through like apt-get or something like that, and then run them. So here is a nice, lovely diagram showing a whole bunch of different tools available to us. I didn't recreate this diagram myself, so you're going to have to put up with the sort of ugly image on an otherwise nice looking slide. That was just going to be too much work. So these are the BCC tools. BCC stands for the BPF compiler collection. And basically, these are just a whole bunch of Python tools that you can install into your environment, into your Linux environment, and just run them. And so an example of that is we have exec snoop. And this allows us to basically capture and output processes that are run on the system by any user, and get things like return codes and things like that. So we have, in this particular case, this is just a really short example where I ran exec snoop and threw out a couple of commands, ls, cat, etc. And here's what we get back. So we get the process ID, the parent process ID. We can get the args as well, the arguments sent to the process. And this is just running on a Linux machine with the BCC tools installed. You do have to run BPF programs as a privileged user, so you do have to sudo them for obvious reasons. I mean, they're code running in the kernel. So next up, we sort of have another program that's kind of similar called BPF trace. This is a collection, again, another collection of tools, but also a kind of custom programming environment at the same time that you can write some of your own functionality using a kind of custom language, basically. In this particular case, here's an example. So I run BPF trace, and I actually give it the command that I want. I want to get the raw syscall for sysenter, and then I want to count, basically, the commands that are being run. And so I ran this for 30 seconds to a minute on one of my machines, and we can see that it basically counts the number of times a certain command was run. In this particular case, apparently Node ran 38,500 times, which is both concerning but also not surprising with Node. So next up, we're going to move on to some projects. And these are open source tools and tools being used actively within the community. They're a little bit more difficult to get started with, but provide a ton of functionality out of the box. So the first one is Cilium. Cilium is an open source sort of networking, security, and observability tool. You can use Cilium for things like load balancing, network policy, flow and policy logging, and even get metrics. It's often used as a CNI provider within Kubernetes. And I think Joseph yesterday actually did a talk talking about how RVU uses Cilium to do cross-cluster networking, which is pretty cool. The next up is Hubble. And Hubble is another Cilium-based project. It's built on top of Cilium and provides a sort of platform for networking and network security using Ebpf. As you can see, I have a diagram down the bottom. It provides a sort of UI and CLI and all this sort of stuff that you can utilize to get a whole bunch of information out of your clusters in regards to the networking occurring. Next up is Falco. I don't think, from what I understand, Falco didn't originally utilize Ebpf. It's what they call a cloud-native runtime security product by Sysdig. It's now a CNCF project. But in more recent times, they've started to utilize Ebpf to implement a whole bunch of functionality. So you can do things like behavioral monitoring. They have a YAML-based sort of DSL that you can write rules and things like that for. You can run it on your systems as a container in a Kubernetes cluster and that kind of stuff. The next up is Tracy by Aquasec. This is a sort of newer project. Same sort of idea as Falco. The Tracy project has sort of two sub-projects. The Tracy Ebpf, which utilizes the libbpfgo library that Aquasec themselves wrote, which is sort of a wrapper around libbpfgo, libbpf. And it attaches to Ebpf events, and then you can use Open Policy Agent to detect behavioral patterns and then notify. You can print a standard out, post to webhooks, that kind of stuff. Catran. Bit of a different one coming back to networking, but this utilizes XDP, which is, I've got a slide later on explaining what XDP is a little bit. But it's basically a layer 4 load balancer created by Facebook. It claims to be blazing fast. So something that has recently come out. Again, a sort of newer project in the scene. And I think this is the final one, Inspector Gadget. Inspector Gadget is a project that is actually sort of wrapping a whole bunch of tools rather than being sort of one tool on its own. It takes some of the ideas from the sort of previous BCC tools and BPF trace that we saw before and creates a project that is able to be deployed into your cluster. You get a crew plugin, which is a kubectl plugin that you can run these tools on any one of your nodes within Kubernetes and get a bunch of information. Pretty cool project, in my opinion. So how do we actually develop BPF programs? So we'll go over some of the basics, and hopefully, if we have some time, we'll get into a demo. So as I mentioned before, eBPF programs attach to events within the kernel. you'll see these referred to as sort of hooks or events or things like that. But effectively, eBPF is an event-based system. So a K probe is basically a kernel probe, and a K-rep probe is a return probe. So it allows you to create programs that will run before and after a kernel instruction is executed. And a good example of a bunch of different things that you can do with this are just capturing syscalls. So when a file is opened and when a file is closed, all this kind of stuff. When an executable is run on a system, a K-probe and K-rep probe are useful for capturing information about those executables. Trace points. Trace points are static access components in the kernel. And what static basically means is that they're codified by the kernel developers. They're made available as a stable form of an API, in terms of being able to inject your program and access those events. So if you write a program for one kernel version, going forward, you can expect some sort of form backwards compatibility, which isn't always going to be the case with things like K-probes. U-probes and U-rep probes are very similar to the kernel probes that we've talked about before, but these hook into programs running in user space, and you can get additional information about those programs in user space. And then we have network events. So the express data path, which is XDP, traffic control, socket filtering. BPF was originally created as a networking, a kernel subsystem for networking. And so the networking aspect of BPF is huge. There's a host of different events that you can attach to. XDP, for example, provides early access to packets before the kernel stack actually processes them. So this is actually really useful for things like load balancers, where you can have an eBPF-based load balancer. And there's a fantastic talk by Liz Rice, who spoke at the eBPF Summit, who actually, she wrote an eBPF-based load balancer live in C as one of the keynotes. And I highly recommend you go watch that. It's actually really fascinating. Maps. So BPF maps are basically data storage. They're a generic data structure, and we kind of know what maps mean as programmers, but maps are actually a whole bunch of different data structures in terms of how BPF considers them. You can utilize maps to share data across different BPF programs, between BPF programs and the user space. When you create a map, you need to give it a few different bits of information. So the map type, and we'll see some examples of those in a moment. And then the sort of key size, value size, max entries, that kind of stuff. So keeping in mind these things are written in C, so we need to provide a memory footprint for these different aspects. And so some of the types that we have available to us are things like hash maps and arrays, obviously. But we have all sorts of different things as well. We have a perf event array. We have stack traces. We have LRU hashes, which are like least recently used sort of queues. So there's a whole bunch of things there. Arrays of maps, hashes of maps. Next up, we got helpers. Helper functions it basically exist in eBPF in order to ensure that we have safe access into the kernel when our programs are executed. We can't interact directly with the kernel from within the BPF virtual machine, but the helper functions give us entry points into the kernel to do certain things. We use helper functions to do a variety of different things. We can interact with maps, we can manipulate network packets, we can get things like PIDs and the C group identifiers, network packets, that kind of stuff. A couple of examples of these helper functions. We have Bpf get current com, which is the current process name. Pretty self-explanatory. And we have Bpf get current PID and tgid. This provides you with a 64-bit data structure that in the first 32 bits, you get the process ID, and the last 32 bits, you get the thread group ID. Funnily enough, there's a bit of a gotcha with this particular helper function. The process ID is the process ID from the perspective of the kernel. So the process ID in this particular case is actually from user space is what you'd see as represented as the thread ID or thread group ID. And the thread group ID is in user space actually what you'd consider to be the PID or the process ID. So it's important to understand that sometimes there's a few gotchas with these helper functions, but there's tons of documentation available, man pages and all that kind of stuff. So how do we actually write Bpf programs? So we have two sort of primary libraries for writing our C-based programs. The first is the BCC, or the Bpf compiler collection. Basically a toolkit around that works around LLVM and things like Clang in order to provide us with a whole bunch of instrumentation and access to various bits and pieces in the C programming language, and then provides Python and Lua front ends. It's probably the most mature of the two. It's been around for quite a long time. The second one is libbpf, which is actually the official eBPF library maintained by the Linux kernel maintainers. So this is a more recent project. It's a little bit less mature, but provides some more low-level functionality. The interface is quite complex and can be confusing at times. But it also adds some functionality, some sort of interesting functionality, such as compile once, run everywhere, which has been a pretty significant challenge in the past with Bpf programs, because they need to be compiled for the specific kernel headers for the machine they're running on. So having compile once, run everywhere is a huge step forward. As support for that continues to be rolled out into new kernel versions and things like that. And then we have libraries from the perspective of application development. So we have quite a few Go ones, Python, Rust, and a few others in various other languages. Sorry to the sort of Java and the Java fans out there and things like that, or PHP, you're a bit out of luck. You'll need to write your own, or just write code in a good language. I'm joking. Adrian's giving me a look. All right, so let's hop over to a quick demo. How am I going for time? We have 5 minutes. All right. So I have a Hello World program here. It is this is just a C file. I have a header file which just brings in some includes. Basically, we start off with this. I'll just create this, make this a little bit bigger. Hopefully, there we go. So in this particular case, we have this SEC function, which we pass in, the kprobe basically that we want to execute, or the attached to. In this case, we're attaching to a system call of execve, and we are printing hello world to BPF print K, which is basically just a trace pipe that allows us to, we can then capture that later on, and I'll show you how to do that. And this is my Go code. The Go code for this particular example is actually quite a bit longer than the C code. I'm using the Cilium Ebpf library to interface with this at the moment, but you can use any one of the ones that I mentioned or showed before on that slide. In this particular case, I have a Go generate declaration. If you're not familiar with Go, quite simple. When I run Go generate, it'll call out to this executable and basically run whatever the instruction is there. So in this case, I'm calling out to Clang, and it's creating, compiling or converting to Go code some information for me to be able to interface with my program. So we do a few things. I've just got like a signal notifier here for when I interrupt. We lock the memory for eBPF sources, and then we basically load our objects into the kernel, and we attach to the K probe. And so what I can do is I've already compiled my program. So I can run my program, and then I can I'm going to forget the command for this. Give me a sec. I've forgotten the command in all my genius. Apparently it's not finding that in my reverse search, that's fine. Oops. And so if I create a new terminal real quick, I can run a few commands. If I hop back into here, it's now not working. Of course not. What we should be seeing there is a whole bunch of hello worlds popping out. It was working about 45 minutes ago. So, but I think you basically get the idea. I'm not sure why that's working now, and I don't have enough time to troubleshoot it. But I will have this code. I'll make sure it's working, and then I'll have this code up on GitHub, and I'll post it for everyone to have a look at. But that's a real simple example. I also have another example which I'll post as well, which is a little bit more complex. I know this one works for sure, which is actually using a trace point to capture our execve system calls and actually grab a whole bunch of new data, a whole bunch of data out of that, and then print it out. And so I'll upload both of those to GitHub and make them available for everybody. And on that note, I'm out of time, so I'll leave you with some pictures of my dogs, Sky and Maru, and I'll say thank you.
Okay, thank you very much, Josh. I think that was excellent. Demo gods aside, I think we all got where you're going with that demo. Yeah, so we've got a little bit of time. So as a quick question, one thing that always strikes me, I'm like eBPF really seems to be taking off, but it's quite a low level technology. So I'm always a little bit surprised by that. Yeah, and I'm kind of wondering, does the sort of average Kubernetes developer, would you expect them to benefit from learning eBPF, or should they expect to learn it? Or
honestly, I think for the average Kubernetes administrator, maintainer, or in terms of people maintaining clusters, for the most part, unless you have a real good reason to do so, unless you're working in the sort of runtime security space, or you're working in the networking, load balancing or security space there, or the observability space, there's a ton of work going on right now, especially in places like Datadog and like Elastic, where they're doing a ton of work with eBPF to get data out regarding application runtime observability and performance. So for the most part, I think the average person is going to be better off knowing about the existing tools that are out there that are taking advantage of eBPF and the sort of power that it brings. And it's a space that's growing really rapidly. And so I would expect to see a ton of innovation in that space for the next couple of years at the very least. But knowing what's out there and how to use those tools would be far more beneficial for the average person than being able to actually write your own.
yeah, so what you'd say is that it's basically enabling sort of the next generation of tooling on Kubernetes effectively and Linux in general.
Absolutely, yeah.
Cool. Okay, I don't think there was any other questions. Let me double check. I don't see anything. Let me check the YouTube actually. Okay. We do have a quick sponsor thing before I hand over to Danny. So yeah, we have several sponsors. We love you all. Control Plane, Storage OS, JetStack, Sneak, Tramshed, Sysdig, and our charity partners, Stimet and Protect Earth, but Storage OS. So Storage OS is a software-defined cloud-native storage platform delivering persistent storage for Kubernetes. Storage OS is built from the ground up with no legacy restrictions to give enterprises working with cloud-native workloads a scalable storage platform with no compromise in performance, availability, or security. For additional information, visit www.storageos.com. That was my best advertising voice. I like that. Okay, so no, but big thanks to Storage OS, and over to you, Danny.
Sure. Our next speaker is Marco Beltz, and he's talking about seamless scaling of Kubernetes nodes. Over to you, Marco.
Cool. Thanks, Danny. Thanks, Adrian. Really impressed with the pronunciation, then. Thank you. All right. Let me try to share my stuff here. Cool. Hopefully everybody can see that. If you can't, please give me a shout. But I will just assume that that's currently visible and in a good shape. So welcome to the last talk of the conference today. I have to say I really enjoyed it so far. I really like the variety of different talks that we have. So all the way from deep down in technology, as Josh did it now, all the way up to high level and kind of environmental talks that I think are quite important as well. So what I'm going to talk today about is we're going to have a look at the seamlessly scaling of Kubernetes nodes. So it seems like a really mouthful title, but what we're going to look into in a nutshell is, are there any alternatives to kind of the auto scaling that we're currently doing in our Kubernetes nodes? So first of all, I would like to start with a quote, "Be water, my friend." And this was actually a quote from Bruce Lee, who was a martial artist, actor, philosopher, and a filmmaker. It was actually captured in the Canadian show in the 70s. It was called the Pierre Branson Show. So Bruce Lee gave a an interview there, and he talked about the mentality and how he approaches things in life. And what he was trying to say with that is that in the kind of highly hybrid and like fastly changing environment, you need to keep your mind open to new things, and you shouldn't kind of cling on to like conventional norms. And that's why he kind of talks about being shapeless, formless, like water. So for example, like if stream goes down the hill, it always kind of tries to adapt to different kind of obstacles along the way and tries to go around it. So who am I? I'm Marco, as already kind of said before. I work as a senior consultant at the Scale Factory. We are remote-first DevOps consultancy based in London, and we're also AWS Advanced Consulting Partner and Kubernetes Service Provider. A little bit of a disclaimer slash kind of a heads up here. Even though we're going to talk about the provider independent solutions today, all the examples and the demo will be shown on the AWS infrastructure. So hopefully you can apply that to different kind of vendors as well. My background is mostly ops, so I have an extensive kind of knowledge with Linux and virtualization from my past kind of engagements. I'm also an open source contributor and a supporter, and a big fan of automation and simplifying things. If you can still remember pre-pandemic, I also really enjoyed traveling, cycling, and hiking, which was a little bit limited lately, but hopefully we're going to get there soon. So what I'm going to cover today is we're going to kind of kick it off with, some scaling foundations. How does the Kubernetes resource scaling look like? We're going to have a look at the kind of automation options there, and going to try to see what the current kind of limitations or drawbacks are using what we're currently using for auto scaling. And kind of going from there, we're going to look at one of the projects that is trying to address this. It's called Carpenter, and is trying to kind of change the idea a little bit around, and it's trying to do groupless auto scaling. So we're going to have a look at the architecture of the project, how they're approaching those kind of problems, how they're doing scheduling, how it's done bin packing, and also the whole capacity lifecycle. From there, I'm going to go with a demo. Hopefully the demo gods are really good. I'm satisfied with the sacrifice this morning, but everything should be on track. And I'm going to wrap it up with some takeaways and project status at the end. Okay, so if we quickly go through the scaling kind of fundamentals. So if you look at scaling, we can either have horizontal scaling, which usually means adding more instances, and this is usually referred to as scaling out. And then you could have vertical scaling, which is usually referred to as scaling up. And in this case, you would add more power to your existing instances. So in terms of Kubernetes resources, we can scale either pods or nodes. And let's first have a look, where do the pods come from actually? So we can actually end up with pods by, manually spinning them up using CLI, or we can actually provision workload resources such as deployment, replica sets, daemon sets, jobs, and those would take care of, provisioning your pods afterwards. Looking from the kind of auto scaling perspective, what we can do here is, in order to react to different kind of environment requirements, such as influx of requests, we can use tooling such as horizontal pod autoscaler or vertical pod autoscaler. Just bear in mind they're mutually exclusive, so either use one of those. There is a different autoscaler available in GCP, which is called multidimensional pod autoscaler, and it's trying to kind of combine both of those words together in order to kind of be able to scale up pods horizontally and also scale them vertically as well as needed. There are also some other tools in this landscape available as well, such as KDA, which is an event-driven autoscaling, or Knative, which is a serverless platform, which kind of also gives us the autoscaling functionality. Okay, those are pods. Let's have a look at nodes now. So obviously, you can also manually provision nodes as well. But from the automation perspective, probably the fact of standard in the industry today is probably cluster autoscaler, which is probably most widely used. There's also a Zalando fork, which is trying to kind of address some of the limitations or kind of caveats around using cluster autoscaler. And there are some less maintainable projects such as Libro and Escalator. So let's have a look into the cluster autoscaler right now. So cluster autoscaler is kind of an industry adopted, open source and vendor neutral autoscaling solution. What it does is automatically adjust your cluster size based on the load that you're currently running. And it tries to be cost efficient. So it tries to keep your infrastructure cost efficient and as lean as possible. It is battle tested, so you can use it up to a couple of thousand nodes with 30 pods per node. And it's using existing cloud building blocks. So for example, on AWS, it would use autoscaling groups in the background. But it also comes with some challenges, right? So because it's kind of relying on the autoscaling groups in the background and the kind of node groups, which are kind of an abstract, term in Kubernetes world. You're obviously limited to specific kind of concept limitations here. So for example, if you want to span across multiple AZs or use different instance types, you would usually need to provision multiple node groups to kind of achieve that as well. So obviously it kind of works on the premise that you're using the same templates in the background, and those would be applied to the whole node group, not specific nodes itself. It's quite complex to use as well. So it has, I think, like over 70 arguments that you can use when you spin it up. It's quite tightly bound to the scheduler. So part of its code base actually uses the specific version of the kube scheduler, and that actually makes it a little bit harder to port, or at least you have to use the compatible version with the Kubernetes version that you're currently using. And it's a global controller as well. So, at this point, there were some smart folks at AWS, and they actually thought, okay, we can probably look at this from a different perspective, and we can probably kind of solve some of this challenges by changing a few concepts in how we kind of provision resources in Kubernetes. So what is Carpenter? It's a node lifecycle solution. It's currently incubating in AWS Labs, also open source and vendor neutral, even though currently it's only supporting the AWS provider for obvious reasons, but it's vendor neutral, and there is a kind of wide adoption plan for later on in the project. And what it's trying to do is, if you look at the diagram here, you couldn't really see the difference from the autoscaler, but the logic is a bit different. So instead of using the kind of the cloud building blocks, it's directly provisioning capacity, and it's doing that by using pod resource requests. And based on those, it's calculating the instance types, because you can actually query for all the instance types that are available to you. And then they try to kind of simulate how those pods would kind of fall into the instance types, and then request the instances that would kind of satisfy the resource requests. They're also generating node properties on the fly based on the pod scheduling constraints. So everything is kind of done on the fly as the request comes in. So it's much more flexible in this regard. So it literally removes the whole node group concept, and thus it's usually kind of referred to as groupless node autoscaling. By doing that, it really lowers down the cloud provider API utilization. So there are far less API calls that need to be executed, and also reduces configuration complexity as well, because it's kind of using the common cloud native approaches to kind of configure controllers using the CRDs. So if I quickly look at the provisioner CRD that you need to kind of use, you can use one or many of them. There is no limitation to it. I mean, there is a question of what use cases would you like to kind of address with it, but let's have a look at the most kind of simple CRD that you can use, which is kind provisioner. from carpenter.sh. And in the specification, you can see it's not a lot of parameters that you would need to provide. So you need to specify a few kind of cluster parameters so it knows which cluster it connects to. I think there is a thing on the roadmap to kind of auto-calculate that in the future as well. And then a couple of others around setting TTLs for nodes and specifying taints for those. And also you can specify additional constraints, which we're going to look into detail in the demo later on. So let's kind of dive quickly into how the launching capacity works. So they're launching capacity by directly executing the API and using the EC to create fleet API calls, and that kind of returns the whole capacity needed. Under the hood, they're using a couple of controllers to kind of launch the capacity and manage that. So there is an allocator controller, which is a fast latency sensitive one, and the reallocator, which is a slow and kind of cost sensitive. And that brings the provisioning latency down from average, which is on average 2 minutes across the providers, down to around 60 seconds, which most of the time is currently still used on provisioning the node itself rather than scheduling. So the scheduling is usually kind of provisioning the resource, and this is implicitly doing the scheduling as well. So whether you like it or not, when you provision a node, you're kind of already hinting the scheduler where this node is going to kind of get spun up. And they're even kind of helping the scheduler additionally by binding it to a specific node, because this is the information already available during the provisioning phase as well. And in order to kind of decide which pods bin to specific nodes, they use online bin packing. It's a kind of well-known term in computer science, and it's an incomplete problem where you try to fit your capacity, kind of request for capacity to a kind of limited capacity you have. And they're using the first fit descheduling, descending algorithm to achieve that. So it's loosely coupled with scheduler, even though it's kind of tightly working with the scheduler, it's not relying on the scheduler explicitly. And if you remember the code before, it definitely sounds like they're trying, or at least the carpenter trying to be more like water. So it kind of adapts to different kind of requests from the environment and tries to be flexible and kind of efficient in provisioning that as well. It also supports all well-known labels to kind of limit where the pods will be assigned to or what kind of nodes you want to provision. So what's left in the lifecycle, capacity lifecycle then? So Carpenter is also kind of taking care of the termination of the resources. So as soon as the node is emptied, the TTL is assigned to it, and as soon as TTL kind of expires, the node is being terminated. They're also kind of making sure that underutilized deleted nodes are cordoned and correctly trained. So there's a finalizer as well. So if you manually delete a node, it will train the node before actually removing it. It's reacting to spots and rebalance kind of termination events, instant unhealthy events. And there is an interesting kind of a use case here as well. You can set an expiration TTL on the node itself, which is a really good use case for compliance. So what you can actually do is set an expiration date or an expiration TTL on a node, and that would ensure that the node would be terminated after this expires. And as you can imagine, this could actually keep your cluster up to date automatically. There is the fragmentation they want to implement as well. It's still in the design phase, unfortunately. But the idea is that you shouldn't be stuck with initial provisioning. So as your nodes become less optimally utilized, we should have a controller there kind of kicking in and taking care of that and just moving the workloads across as requested. Obviously, that comes with additional complexities and different challenges, which are trying to be addressed in the project as it kind of goes along. Okay, before we dive into demo, I would just like to kind of set the scene real quickly. So what we're going to do here is, as I mentioned before, we're going to run the AWS EKS, which is a managed Kubernetes cluster in AWS. We're going to use Fargate profiles. And the reason why I think this is a really good use case for Fargate profiles is because obviously there is a chicken and egg problem, right? So you say, okay, I want to deploy a an auto-scaling solution, but obviously you need to kind of provision it somewhere. So either you statically provision a node and run it there, or you can just use AWS Fargate, which is a serverless solution, kind of nicely embedded into the EKS, where you can just delegate everything to AWS, and they will kind of provision the underlying resources for you. And I think provisioning Carpenter and the kube system namespace there is a really good use case here. So as soon as we add workloads, the Carpenter will take care of and provision our non-Fargate workloads and schedule the workload there. Cool. Let's quickly switch to console and let's see what we got here. Hopefully that's big enough. Adrian, please shout if this is too small. I can make it bigger. I will take that as a yes. Cool. Let's have a quick look. So what we are currently running in here. What I'm currently running in here is, like I mentioned before, it's a kind of a vanilla cluster. It doesn't have anything in it. We just run core DNS. There are proxy and CNI bits waiting to be spun up as soon as we have additional capacity available, but they are not necessarily needed for the cluster to run. And we obviously run Carpenter controller and a webhook.
If you can make it any bigger, Marco, I think that would be good. When it goes through to YouTube, it's a little bit
small.
Yeah,
absolutely. Better?
Even bigger, I think. Yeah, good. Thank you.
Perfect. Let me make the other ones the same as well. So we're going to end up on the same thing. Okay. So this was actually deployed using an upstream Helm chart, which makes it quite easy to deploy. And we're using the latest version to achieve that. So what we're going to do first is let's quickly have a look. We need to deploy a provisioner. Like I said before, we're going to use a provisioner. We're going to connect it to the cluster we're running it in. We're going to say TTL seconds after empty to 30. So it's going to terminate nodes after 30 seconds after they're being emptied. And we're going to limit it to 2 zones, only 1A, EU West 1A and EU West 1C. So we shouldn't be getting any nodes in EU West 1B. And we're going to limit the instances to a specific set of instance types we want to use. So obviously we don't want to use super expensive ones, and we want to avoid the small ones as well. Okay, let's quickly provision deploy the provisioner. So the provisioner is deployed now. And the next thing we're going to do, we're going to kind of run a really simple deployment. So what it's going to do is just going to use a pause container, so nothing really fancy. And the reason why we're doing that is we're going to request a 1 CPU. And the reason why we're doing this is by using CPU requests, we're going to force the resource exhaustion, and thus the Carpenter should kick in where Kube Scheduler won't be able to kind of schedule the pods anymore. Okay, so let's create a deployment. So we're going to quickly check the pod. So we're not running anything yet because deployment is currently scaled to 0. And what we want to do here as well. So what I'm going to open here as well is, I'm going to open logs from the Carpenter controller. And the next thing we're going to do, we're going to watch for the number of nodes that we're currently running. So currently we're only running 4 Fargate nodes to kind of run the Carpenter and the core DNS and nothing else. And what we're going to do here first is we're going to scale the deployment up to 1, right? So this is very simple, scaling up to 1. And as you can see here is we don't have any capacity available yet because the default namespace cannot be scheduled on Fargate. Thus, the scheduler marks this pod as being pending, so it's currently unscheduled. As we can see in the logs from Carpenter, you can see that Carpenter actually detected that. It kind of seen that there is a 1 unscheduled pod, and it actually calculated the instance that we can actually use to kind of schedule this pod on. So it's computed it. There was a set of instances that we can use, and it decided that the most appropriate one is actually c5.xlarge. And because we're using constraint, it's going to go to EU West 1A. And if we look at the nodes, you're going to notice that there is already a new node being spun up. Currently, it's in the unknown status because the node is still booting. Oh yeah, here we go. It's not ready currently, but as you can see, in about like 60 seconds-ish, to actually get a new node provisioned with an instance type that kind of could fit the workload, and it's limited to a specific zone that we specified in the provisioner as well. So if we quickly have a look at our pods, you can actually see the container has already been created, so the image is being pulled down, and the container should be up and running already. Okay, so let's move forward. So let's say we want to scale it even further, right? So let's scale it up to 3 replicas now. So if we look at the containers now, you're going to notice, oh wow, all 3 of them are already running. And the reason for that is because the instance that has been spun up had enough capacity to kind of schedule those. And if you look at the log, there is nothing in log. So Carpenter didn't actually kind of kicked in because the controller loop didn't detect any of the unscheduled pods. Okay, so let's scale it even further, right? So let's scale it up to 7. This should kind of kick it in properly. So as you can see, we ran out of resources, CPU resources on the node, and we ended up with 4 unscheduled pods. And Carpenter detected again, we have unscheduled pods. It tried to kind of do the bin packing and calculate from the instances that we are limiting it to, which one could actually be used to fit 4 additional pods. And it decided the C5 to X large should be good enough to kind of provision it. And this time it actually went with EU West 1C, which is another zone that we kind of limited to. So there was another loop going through. As you can see, the second loop actually didn't find any provisional pods, so it kind of stopped there. As we can see here again, another node is coming up, and it's currently being bootstrapped and provisioned, and should get added to the cluster in a bit. So as you can see, the instance type is as requested, and it's going to 1C zone. So let's have a quick look. As we can see, the containers are already being created, and let's wait a couple more seconds. So we get the image downloaded. You would expect quicker response times from the cloud providers, but I'm sure it's going to be running soon. So yes, we have it running. So what we can do actually now is, like I mentioned before, it does attach a kind of a lifecycle hook to a finalizer to the node lifecycle hook. So if we decide to say, okay, we're gonna terminate one of the nodes, let's pick this one, and say, okay, we're just gonna delete the node, right? We don't want this node, or you can imagine the TTL expired, so the node expired, it's just gonna go away. And what is gonna happen here, you're gonna see, as I said before, there is a termination controller, which is kicking in now because of the finalizer, it's being kind of triggered. And it cordoned the node, so the node has been cordoned, and the pods are currently being evicted from that node to the rest of the capacity. Because we provisioned enough capacity that can fit all the other nodes, so all the nodes can actually be scheduled. And if we check the pods again, obviously all the pods were successfully scheduled to the existing node, and we should actually end up with only one node kind of serving the whole capacity, which is what we expected. So you can see it's kind of nicely interacting with manual interactions as well. Okay, let's say let's quickly scale that down to 0 and see what happens now. So if we check the pods now, you're going to see all the pods are being terminated at this point. And as soon as all the pods are terminated, if we look at the controller, it has detected the underutilized node, or better say the node was empty, and it added a TTL to that specific node saying the node is empty, let's mark it with a TTL, and if there is no workloads going to be scheduled in the next 30 seconds, it's gonna start terminating the node. Obviously, it's gonna first cordon it as usual and then delete the node. And this actually deletes the node, not just from the cluster, but also in underlying cloud provider as well. Okay, what else can we do here? So let's say we don't want to use the x64 x64 architecture, and we want to use the ARM64. So what we're going to do, I'm just going to quickly patch the deployment. So I'm going to change or add the node selector to our deployment, saying that our pods need to be provisioned on ARM64. Let's scale that up now to 1 first. So what we're going to notice here is the allocator controller initially kicked in, found there is a pod that needs to be provisioned. Obviously, it wasn't scheduled, and it immediately started provisioning a new node. And based on the original constraints, it only picked from the ARM nodes that we specified in the provisioner, and we only kind of limited to 4 of those. And based on the requirements, it picked the smaller one that can actually fit everything in. And as you can see here, it's already being provisioned. And like I said before, in around a minute or so, the node should be up, added to the cluster, and ready to take on the workloads that are currently being waited to be scheduled. So I'm just quickly going to see. Yeah, it's still pending. If we switch back to our nodes, so about a couple of seconds more, and the node should be up. Here we go. It's using the Graviton instances, and it's being provisioned to EU West 1A. And if we have a look at our pods, as you can see, the container is already being created. So the pod was obviously scheduled, and it should enter the running state immediately. So just before we wrap it up, what I want to show you is as well how quickly it reacts to changes. So let's say we want to scale up to 100 instances, right? Which might seem a bit absurd, but if we check, you can see we have all those kind of pods in a pending state. And Carpenter is initially kicking in, finding the resources we need to kind of satisfy that, and initially immediately start kind of initializing the bootstrapping of the nodes, and kind of bounding the pods to nodes already. So as you can see, it immediately added additional ARM nodes, which are going to be provisioned, and the pods are going to be, as soon as that provision, the pods are going to be assigned and kind of run on those nodes. So I think I'm kind of running out of time slowly, but I'm just going to wait a couple of seconds just to kind of show you that we are running the capacity we kind of requested. It's limited to the AZ that we wanted to. It's using the largest capacity available from the list, and we should be getting our workloads kind of scheduled immediately after the nodes are available. So as you can see, the containers are already being created. Cool. All right, that concludes the demo. I'm going to quickly switch back to my slides. There is one more left. So there is quite a really good roadmap available on the GitHub. So quickly, what the plan is, so for the rest of the year, so for Q4, the plan is to support all non-use cases and rigorously kind of test for scale and performance. And there is some work left for the future as well. So as I said, they want to improve the heuristics, and there is the fragmentation that's still missing. And there needs to be a better kind of AMI support, because currently they're only supporting BottleRocket or the Linux 2 AMIs from Amazon. So for my talk, what I really want to kind of summarize on is capacity planning is really hard. It's not easy. And what we get by using a solution such as Carpenter is it eliminates the node group kind of requirement, kind of breaks the typical kind of constraints there. It directly kind of requests for the capacity, which gives us the flexibility and also the efficiency. It lowers the complexity of configuration. It's portable by design and quite performant as well. So going back to the quote, it definitely seems like water-like scaling. So trying to reduce and avoid friction with, working closely alongside with existing kind of concepts like Kube Scheduler and efficiently responding to dynamic requests from the environment. I'm going to share the slides afterwards, so I'm going to leave you some further reading, and please do keep in touch. And I'm happy to answer any of the questions that might come across. Back to you, Adrian.
Oh, thank you very much, Marco. I think that was excellent. There's a lot of in-depth knowledge there. And yeah, I think it's one thing that trips up a lot of people. They don't realize how hard like scaling is. We do have a question from Tim Bannister, who asks, can I use Carpenter to skew (bin pack) my workload onto the most cost-effective set of nodes? What other components would I need to make that work?
So yes, they would automatically try to pick the most cost-effective instance types that your limit is to. So you can already achieve that. But like I mentioned before, unfortunately, the defragmentation is not implemented yet. So you would end up with the initial kind of resources that would be provisioned, and it wouldn't be kind of optimized for the workload. But if the nodes get emptied, that would definitely get kind of shut down, and it already works like that.
Okay, excellent. I do have another question. So are you a big Bruce Lee fan then?
Not a really big fan of it, but I do like the philosophy behind it. So yes, that's why I actually picked the quote. So yeah, I think it really kind of nicely kind of goes along with the zeitgeist of this project. So yeah. Okay. How about you? Are you a fan of him?
I quite like Jackie Chan as well. Some of those movies are fantastic.
Cool. Yeah, absolutely.
I appreciate the philosophy as well. Okay, I'm going to hand back to Danny now, because I believe we have another message to read out.
Yes, one more message for Control Plane, who's the final sponsor for the event. So Control Plane are a London-based cloud-native technology company, and they help to keep people safe online. They work with cloud providers, banks, insurance companies, and governments to secure the building blocks of the internet with consulting, training, and products related to cloud-native development, security, and operations. They're trusted by Google Cloud, the UK Home Office, JPMC, among many others. Their clients are world-leading organizations. So thank you very much to Control Plane for sponsoring Kubernetes Community Days UK 2021. And with that, I would like to hand back to Paula for the final conclusion slides.
Fantastic. Thanks, Danny. And thanks, Marco, again for that talk. So we have reached the end. We've reached the end. It's been an amazing couple of days. So I'm going to run through just a few thank yous and an ask as well. So thank you all, first of all, to the audience. Thank you, everybody who joined. Thank you to everybody who asked questions, who gave us feedback. We really appreciate it. And I hope you enjoyed it as much as we enjoyed organizing it. We want to obviously thank all of our speakers, without whom we would have absolutely no content. And it cannot be underestimated the work that goes into preparing a talk and giving the talk. And so we want to say a massive, massive thank you to all of our speakers. The content will all be available on our YouTube channel. We just need to chop them up, splice them, put them out there, but they will all be available as soon as possible. And I really would recommend, if you missed any of the talks or if you were torn between track 1 and track 2, please go and check them out, because there were some really, really fantastic talks. Thank you again to all of our sponsors. So hopefully over the last couple of days, we've read out all of the facts about our sponsors. But again, without our sponsors, we wouldn't be able to run this event. So thank you to Tramshed for doing the AV. Thank you to Sneak, to Control Plane, to JetStack, to Sysdig, and to Storage OS. Thank you to all of you.
Thanks.
Workshops. So at the start of the week, we had 3 workshops running on Monday and Tuesday. So thank you to JetStack and to Control Plane and to Solo. But the fun's not over yet. So if you are still keen to join a workshop, we actually have 3 more workshops coming up. So tomorrow we have workshops from Container Solutions and Sneak. And on Monday, we have a workshop from SUSE. So if you're feeling ready for a workshop, we have a couple more days of fun lined up for you. Thank you to our watch parties. So for anyone who attended in Cardiff or in Manchester, I hope you had fun. I hope our hosts took good care of you. If they didn't, please feel free to provide us feedback, but hopefully you enjoyed it. We also have, I think, a couple of social events happening this evening. So if you're in Cardiff and you want to go drinking with Lewis, then please do. Or if you're in Birmingham, I think the Cloud Native Birmingham meetup group also might be doing a social tonight. So please feel free to go along, talk about what you've seen, what you've learned. Should be good fun. Want to do a quick shout out again to our charity partners. So this event is not for profit. Everyone who has participated in it as an organizer, we don't get paid for it. The money that we have has come from the sponsors, and the leftovers from kind of some of the costs will all go to charities. So we had Florian speaking yesterday about the work that STEMETs do. We had Phil speaking today about the work that Protect Earth do. And we will tot up the numbers and make the donations as soon as we possibly can. But we're really delighted to sponsor these 2 UK-based charities. It's still not too late to sign up for swag. It's nearly too late, but not quite. So if you haven't yet signed up and you would like some cool swag coming from us and our sponsors, go to our website. I'd say probably by the end of the week is when you've got till end of tomorrow, let's say. We do have our Twitter handle still going, obviously, so you can provide us feedback or thoughts along in Twitter. And I mentioned the YouTube channel. So all the talks will be available on YouTube. On our channel, I know the streams were split on 2 channels, but all the replays will be back on our channel. So you're able to go there and check those out. We would also like feedback. So it's been an amazing couple of days. It's been an interesting few months. We've worked hard to put this event on, but we also want to learn and improve. We might do it again. Who knows? We'll see how we feel, but we would still love to get your feedback. If there's things we could have done differently, things you'd like to see for next time, we would love to hear it. Who knows if we could do an in-person event next time, but please give us feedback. You can send it to our email or you can message on the Slack channel. We're all about continuous improvement. So please share feedback with us. And finally, I would like to thank my co-organizers. It's been real, it's been emotional, but it's been a lot of fun. And if anyone is watching and thinks they would like to help organize such an event next year, please do. This is for the community, by the community. So if you have good organization skills, or you're good at raising money, or you're good at corralling speakers, whatever your skill set is, we would love to have more people helping us.
Yeah.
And I think that's it.
While we're on that, just on behalf of the organizing team, we wanted to give a special thank you to you, because I think without your efforts, this event would not have happened. So that's from all the organizers, a big thank you.
Oh, thank you. You make me embarrassed. Thanks, Matt. And I think that's it, folks. The show is over.
Yeah, back to reality. I need to lie down.
Super. Well, here's some of the team you've seen us over the last few days. Like I said, please give us feedback, and hopefully we'll catch you at a KCD UK 2022 event. Who knows? Let's hope. Thanks, everybody.
Bye.
Thanks, folks. Thank you.